Hello, everyone. A confirmation about the audio, please. How are you guys doing? I'm doing fine. Thank you. Perfect. I'm good. Thank you. Weekend was the environment sessions. Gulam, if you have basically taken a look at the previous lectures, even so slightly, it won't be much of an issue. And from here also, just try to follow the basics because still we are very much in the basics portion. And I would suggest to you that after today, try to have a revision of the previous couple of modules, and so that you are able to follow the next portions to be covered, because in climatology the most difficult of the concepts that are supposed to be there, we are yet to cover that. So including the portion of the jet streams, including the portion of when we talk about enzo cycles, Indian monsoon eventually. So try to ensure that you are able to revise in time. So now that couple of weeks of geography is something that you have attended, I want to gauge a comfort level from your guy, from you guys. What is the comfort level in general, not for the session, but for the subject? That is much more important. Are you guys comfortable? Is it something that you feel that you are able to cope up with, or do you want to quit the subject immediately and start with subjects like polity again? Is there a UPSC change of syllabus in 2025? No, no. Don't go through the various different rumors, etc. As of now, just concentrate on the studies. Moderate stage is good. Moderate stage is good. See, it is because slowly and steadily, as and understand the progression of it, because I'm sure in the first session, the type of questions that you guys asked, now I'm sure those kinds of questions you don't have anymore. That what are latitudes, longitudes. So, slowly and steadily, as you will be able to look at the larger picture, many of the doubts automatically are cleared in the way. Roshan, yes, I have seen the 2023 CSAT paper. Good. Good to hear that. And basically, Raja and Chandrasekhar, just understand that the subject of geography is something, the ease of it is about imagination. The more you are able to imagine what would happen and more you are able to associate with your surrounding condition, it is something which is much more easier to handle. Abhishek, try to revise the portions which have already been covered through the recordings, and that will provide a kind of a basis for understanding the next modules. Because please understand, as I already told, that as I've already referred, that there are many different portions and complex concepts which are still to be covered. So the more you are able to indulge in those discussions, in those deliberations, it is always going to help you. Why did live chat of daily news analysis is stopped? There have been certain reasons for it, and because in the name of live chat, obviously, I'm sure any of you who have been watching YouTube videos, you know what goes on in the name of live chat. So that is where, in order to improve the productivity, you have told that asthenosphere lies between the outer and the inner mantle. No, it is not at the Repeti discontinuity, Mayank. Asthenosphere is still very much in the outer portion of the mantle. And because understand, mantle extends up till a depth of 2900 kilometer, and asthenosphere will extend at max up to a depth of around 350, or in certain areas even 400 kilometer. So still very much a part of the upper mantle, but then above the asthenosphere also you have some portion of solid upper mantle which is present. Sindhu, I felt the topics are done but not enough to answer the weekly test. Could you please point out any of these questions, Sindhu, where you found that there is a significant amount of difficulty that you faced which you have not covered in the class? Manikandan, horizontal winds are affected by only PGF. How gravitational force affects horizontal wind movement? Because that ensures that the wind doesn't immediately start rising up. Because if the gravitational force is less, the air molecules will start rising up. The density will be less. So the horizontal movement will be inhibited quite significantly. Okay. Yes, asthenosphere lies above the discontinuity. Okay. So, hello, a very warm good evening to all of you, and welcome to Baiju's Exam Prep IAS. Welcome to another session of climatology, where we shall be talking about the other factors which end up influencing the wind movement. We are going to take a look into the various different permanent types of winds which are moving across the entirety of the planet. And then we are going to understand the aspect of the local winds. I'll give you the list of the local winds which are relevant for your prelims only. And then after that, we are going to look into the portion of humidity precipitation, in the sense that what is more important there, that is how is it that the clouds are formed, what are the classification of clouds, why is it that we experience thunderstorms, lightning, etc. Okay. Have we, parasitic cones? We have covered parasitic cones. Parasitic cones and role of mantle plumes we have discussed, isn't it? But we have certain types of PYQs of geomorphology that we are going to have a discussion for today as well at the end of the session, while we discuss the PYQs of some of the portions of climatology. I'll again pick it up, and by that medium, I'll again be able to tell you and repeat it again what is the role of mantle plume and so on. So, in the last session, we had looked at what do we understand by pressure. So, just a brief recap of it. Pressure of air, or air pressure, is basically referred to as the total amount of weight which is induced by the topmost air portion, or the air portion from the top to the surface itself. That is what is referred to as the atmospheric pressure. Now, this atmospheric pressure is something which can reduce, it can increase depending upon various conditions. It can be dependent upon temperature, where we have seen that if the temperature is high, the air can rise up. If the temperature is cold, the air becomes heavier and starts sinking. So, whenever you have a rising air, that represents a low pressure. Whenever you have a sinking air, that represents a high pressure. But then it is not only temperature which can contribute to the pressure change. In many of the areas, we also come across the fact that, for example, if let's suppose on the ground surface you have a convergence of air, and from two areas the winds converge. Now, then they will have no other place to go but then to be pushed up and rise up. So, when they rise up on the ground surface, they will create a low pressure. Now, that low pressure which is created just by the collision of the wind and the rising of the air, that is independent of temperature. Similarly, if let's suppose in the upper portion of troposphere, you have winds which are coming, colliding. Now, those winds again have no other place to go. They cannot simply penetrate into the region of stratosphere. So from there, the winds are pushed down. They hit the ground surface and then they diverge in different directions. Again, this particular motion is independent of temperature, and this particular motion is going to create a kind of a high pressure on the ground surface. So pressure is something which can be contributed by either temperature or by the pure movement of the wind pattern as well. Now, we have also seen that always winds will blow from a high to a low. Always. That means winds will always be blowing from a high pressure to low pressure. But what are the factors which influences the wind movement? One of the factors is the pressure gradient force. That is the difference between high pressure and low pressure. And the simplest analogy of it is to be able to understand how water flows. Now, when you have a flow of water, you will always observe that water never flows from a lower level to a higher level. Water always flows from a higher level to lower level. That means wherever there is a height gradient, right? Greater the height gradient, greater will be the intensity of water flow. Similarly, in the case of the wind, greater the pressure difference between the high pressure and low pressure, stronger will be the wind movement. And that difference between the high pressure and the low pressure, that is indicated by pressure gradient. And wherever pressure gradient does exist, that will always exert a pressure gradient force which will influence the movement of the wind. Now, that is where whenever you experience a wind blowing or a cool breeze blowing across, always you will find that this wind, whenever it blows, it will be moving towards a low pressure region. So if from the next time, let's suppose you are facing the wind or the wind is blowing from any particular direction, always you will be able to guess where or in which direction the low pressure might exist. More stringent or more acute the low pressure, stronger will be the wind movement. That is why when you have very strong winds, understand that in some region or in your region itself, the low pressure might be very acute. But then, when the winds move, when the winds blow, their directionality is also impacted. And that is impacted by the rotation of planet Earth on its axis. Had the planet Earth not been rotating on its axis, then there would not have been any kind of a bending of the wind. That would mean if a wind would originate, let's suppose, at the lower latitude at the equator, the wind would automatically end up reaching wherever it would want to. But because the planet is rotating, the winds they end up deviating. They deviate from their path. In the northern hemisphere, they always will deviate to the right. In the southern hemisphere, they will always be deviating to their left. Now, how do we understand first the very basics of it? How do we understand in which direction the deviation is? So always, if you have to take the case of whether it is bending to the right or the left, always take a note of the direction of the wind, the origin of the wind. So for example, if a wind is moving like this, its rightward bend will be here, right? And if a wind is moving like this, its rightward bend will be in this direction. So how do we understand which is the rightward or the leftward bend? So the easiest methodology for that is always imagine yourself to be standing in the direction of the wind. Imagine that the wind is blowing and originating from your direction and moving forward. Your right hand side will be the rightward bend, your left hand side will be the leftward bend. Now, that kind of bending which happens, that is aided by the rotation of the planet Earth on its axis. That is referred to as the Coriolis force. Now, this Coriolis force is an apparent force. It is referred to as an apparent force. Why? Because this will act on only those objects which move freely over the surface. If you have a car or a vehicle with which you are moving across the surface, they will never experience the bend because that is also rotating across the planet. But let's suppose there is an airplane moving from one region to another. Let's suppose there's a wind moving from one region to another. Let's suppose there is significant amount of oceanic water in the oceanic current moving from one region to another. Oftentimes, they are independent of the rotational motion of the Earth. And as a result, they will experience a bend. This is the Coriolis force. We'll understand the reason for that as well. Something that we covered in the first class itself. And if you recall, that in the first class itself, I told you, well, we're discussing about the speed of rotation of the planet, that there will be relevance of this when we come to the portion of climatology. We'll see how. So the Coriolis effect describes the pattern of deflection taken by objects not firmly connected to the ground as they travel long distances around the Earth. This is purely impacted due to the rotation of the planet. Purely. due to the rotation of Earth. Now, what happens due to the rotation of Earth? Now, we have earlier seen that as the planet rotates, now here, if an individual, let's say, is placed here at A, if let's suppose someone is there at B, if suppose someone is there at C, if suppose this is the polar region at D. Now, as the planet rotates, will all of them indicate the same speed of movement, or will the speed of movement for each of them be different? Apply the logic. Very good. It will be different for all of them. Why? So the speed of rotation at A will be different than the speed of rotation at B, will be different than speed of rotation at C. That will be different than the speed of rotation at D. Now, please don't get confused that the planet is a continuous body, it is a sphere. So how can different materials move at different speed? It follows a very simple principle, and that is the principle where we talk about that speed is equal to distance upon or distance traveled by time. So, because Earth is a spherical object, so different places, be it A, B, C, or even D, they will be covering different distance in one rotation. Let's take the case of time for one rotation to be 1 day. So here, speed at A, so that would give you the distance traveled by A divided by 1 day. Speed at B, distance traveled by B in 1 day. Speed at C, distance traveled by C in 1 day. Speed of D, distance traveled by D in 1 day. So in 1 day, A moves the largest distance. Why? Because it covers the largest circle across the planet. That is the equator. B will have a lesser distance traveled because it covers a path of a smaller circle in comparison in 1 day. C will end up covering even smaller circle. And what about D? In one rotation, D will not end up moving at all. As the planet rotates, it is the polar region which are almost consistently in one place itself. Take any globe, for example, that you would have played with or that you would have had from your childhood days. As the and in any globe that you would see that it is hinged from both sides, and the entire globe or the sphere rotates. So that in itself tells you that the hinges which represent the polar region, they don't move significantly in one rotation. So we have distance traveled by A is the maximum. It is much greater than distance traveled by B. It is much greater than distance traveled by C. And that is going to be much greater than distance traveled by D. And distance traveled by D is equal to 0. And if we take the time to be 1 day, that is in one rotation, it takes 1 day to complete one rotation. The planet takes 1 day to complete a rotation. So that is where you will find that speed at A will be much larger than speed of B, will be much larger than speed of C, will be much larger than speed at D, and speed of rotation at D will be 0. So here, when an object moves between the different latitudes, we can say in either of the directions, we can say that the object is moving from a region of one particular speed to either a higher speed or a lower speed. And that is why the object indicates a deflection. So as the object, or as there is a movement from one portion to another, that means movement happens from one speed to a higher or lower speed. And this causes deflection. We'll take the example of this as well in order to understand it better. But here is the written text to make you a bit comfortable. So the key to the Coriolis effect lies in the Earth's rotation. Specifically, Earth rotates faster at the equator than it does at the poles. Earth is why? Because Earth is wider at the equator. So to make a rotation in 124-hour period, equatorial regions move at close to around 1600 kilometers per hour, whereas near the poles, the Earth is almost, and that location almost does not move significantly. And its movement is close to around 0 kilometers per hour. Now let us understand that how is it that you have different and an object moving between different speeds? How is it and why is it that they indicate a kind of a deviation, or why is it that they indicate a bending? So we'll understand the case of the cars, right? The car example is something that we will take. And here I want you to relate it with your day-to-day life as well, something that you would have experienced on a daily basis. While you move on the roads and the traffic that you encounter, I'm sure you would have encountered this as well. Suppose I consider two vehicles, both of them, let's assume, moving at a speed of 40 kilometer per hour. Okay, let's assume 40 kilometer per hour. Now, as they are moving at 40 kilometer per hour, let's name this as car A and car B. Now, if an individual, and you would also have observed that when, let's suppose, many of the times you do that, or you would have done that, especially in the teen years, this is something of a very common thing to do. When you have separate vehicles for your friends as well, all of you block the entire road and move at the same speed, having a full on conversation. So suppose an individual from car A throws a ball, right? Now, will that be caught by a person sitting in car B or not? It will be, because with respect to car A, car B is also moving at the same speed. So this will be caught by the person at car B, isn't it? Now, this is our first case. We'll make the conclusions later on. So this is our first case. Let's consider another case. Let's assume I have car A and car B. This time, B is moving at 40 kilometer per hour, and this is moving at, let's say, 120 kilometer per hour. Now, in this case, if you carry out the same exercise, that is, from A, someone throws a ball. Will the person at B be able to catch it? If, let's suppose, a car is zooming past you with a very high speed, and if that person throws something, will you be able to catch that if you are moving at slower speed? No. In that case, what will happen? Does the object fall ahead of you, or does the object fall behind you? What happens? Will it fall ahead or will it fall behind? Perfect. It will fall ahead, because A is moving at a much faster speed. So even the ball will have some amount of velocity. So the ball obviously ends up falling ahead of you, because you are moving at a slower speed, isn't it? Now, let's consider a third case. Now, here, I consider a case of A, I consider a case of B. This time, A continues to move at 40 kilometer per hour, whereas B, let's suppose, is moving at 160 kilometer per hour. Now, this time, someone again throws the same ball or the same person throws a ball at B. Now, in this case, what will happen? Will B be able to catch it? No. Will it fall ahead or behind? It will fall behind, because by the time that the ball reaches here, B would have reached somewhere here, maybe. B would have reached much farther ahead. So, for a person standing on the ground, if he has to report it, what will he report? That the ball which was thrown falls behind B. Isn't it? Because by that time, B would have moved significantly ahead. So, let us frame conclusions based upon these simple principles. So, here, when we talk about it, the first conclusion, if you have object moving between same speed, we can say that there is no deflection or no deviation which is happening. When you throw the ball, the other person will be able to catch the ball as well. If the person is good at catching things, the other person will be able to catch that thing as well. So when an object moves between similar speeds, there is no deflection. Okay. Then here, when we talk about the second case, in this case, when an object moves from a faster velocity to a slower speed, object falls ahead. That is going to be my second conclusion. And my third conclusion is going to be, when an object moves between slower to faster, their object falls behind. Right? These are my three conclusions that I can have with the aspect of the relative velocity or the relative speeds between two objects. Now, here, for one final time, I want you to apply your head and apply your logic here. Now, in this case, I have taken the example of 40 kilometer per hour and 160 kilometer per hour. So here I have seen that once a person throws a ball from A, by the time that it reaches B, B would have zoomed ahead. So the object falls behind. So there is a kind of a significant distance that the B would have moved, and then hence a person standing on the ground can note that the object has fallen behind. So if I ask you that, if we talk about it in the terms of deflection, if the difference in speed between A and B, listen to this carefully, if the difference in speed between A and B, if that is higher, will the amount of deviation be higher or will it be lower? That means if A would have been moving at 10 and B would be moving, let's say, at 200 kilometer per hour, would there be greater amount of deviation as compared to earlier, or would there be lesser amount of deviation as compared to earlier? Higher. Very good. Right? Because the distance would also increase. So that tells us a very important conclusion, and that is, greater the difference in relative speeds or relative velocity, greater is the amount of deviation. Right? Let me have this as 4. So we have these 4 conclusions. Based upon that, let us understand why is it that the bending happens whenever you have a wind movement or even an airplane movement, a missile movement. There is a natural bending which happens. Why does that happen? So here, when we talk about, let's say, the planet Earth, let's consider this. Now, or let's do one thing, let's consider a bigger case. Now here, let us consider different regions here. We'll consider first of all the equator. Then let's consider a region slightly above equator, a region slightly below equator. Let's consider a region here. Let's consider a region here. Okay. Now, let's have this as A, B, C. Okay. Now, first of all, let us consider an object which is moving from A to B. Let's suppose an object has to move from A to B. Now, if an object is moving between A to B, we do know that the speed of rotation is maximum at equator and is 0 at poles. Let us write it down here itself. Speed of rotation is maximum at equator and 0 at poles. Right? Now, if an object is moving from A to B, so in this, can we say, or will it be okay for us to conclude that the object is moving from a faster speed to a slower speed? I think everybody will be fine with that. That an object is moving from a faster speed to a slower speed. What did we see earlier? When an object moves from a faster speed to slower speed, object falls ahead, right? So here, rather than reaching B, the object will reach somewhere here, B dash. What about the opposite of it? If let's suppose an object has to move from B to let's suppose A. Now here, if the object is trying to move to A, now can we say it is moving from a region of slower speed to a region of faster speed because A is moving significantly faster? So when anything moves from a slower speed to a faster speed, what happens? It falls behind. So here, rather than reaching A, it will fall behind. It will reach somewhere here, A dash. Now, what is this bend? This is the rightward bend. For both of these cases, this is the rightward bend, isn't it? So here, you will have the rightward bend. What if we consider the same thing between C and A? If an object, let's suppose, has to move from C and has to move to A, from C to A, can we say that it is moving from slower speed to faster speed? We can say that. As the object is moving from C to A, it is moving from slower to faster. And slower to faster, what happens? In this case, observe, it falls behind. So rather than reaching A, this will deviate. This will fall somewhere behind a double dash, let's suppose, isn't it? And here from A to C, if it is trying to move from A to C, it is moving from faster to slower. That means it will fall ahead somewhere. So it will fall ahead somewhere. C dash. Now, what is this deviation or bend? This is a leftward deviation. The movement is to the, or the bending is to the leftward side. So we can say leftward bend. Right? So that gives us the conclusion. Any object moving in the northern hemisphere, freely moving, not that I was moving in the scooter and it did not bend to the left, it was moving in the straight road. So don't have these examples. Let's say an airplane moving, or let's suppose a wind motion, let's suppose even for that matter, if you launch a missile, for that matter a rocket, anything. So when they are moving in the northern hemisphere, they will always be bending to the right. Whenever they are moving in the southern hemisphere, they will always be bending to the left. Now, let us consider a few other examples. Imagine an object which is trying to move from here. Let's think this as 1. Let's think this as 2. Now, both these areas of 1 and 2, their radius will be almost similar to the region of equator. The radius will be almost similar. So we can say that both these regions of 1 and 2, both of them will be moving at the same speed, isn't it? So when an object moves between the regions of the similar speed, there is no deviation. So here, if an object tries to move here, it will reach there without deviation. So that is why it is said that Coriolis force is absent at the region of equator, because immediately above and below the equator, the radius is the same, so the objects end up moving at the similar speed. So here, no deviation. That is, no Coriolis effect. Now, what if I have another consideration that I take? For example, let's suppose I take the case of D here, the poles. Now, in the case of D, speed is equal to 0. Now, even if I consider any region here, any of the region here, let's consider this E. Now, what will be the difference of speed between E and D? It will be very high. Difference of speed will be very, very high because D is 0. So whatever be the speed at E, it will add on to the difference, right? So because the poles are rotating at a speed of 0, they are not moving at all. We can have a conclusion that from any particular region, if you consider, there will be always a very high amount of difference between the polar region and any other region. Now, what have we seen earlier? Greater the difference in relative velocity, greater is the amount of deviation. So any object, whether it is moving to the poles or whether it is coming from the polar region, if the speed of, or the difference of speed is very high, there will be greater deviation. And that means it is in the region of the poles here, as the difference of speed is maximum, that means the deflection is maximum. That means Coriolis effect is highest. Effect is highest. Okay, why? Because Just give you an example, between A and B, if A is moving at 1000 kilometer per hour, B is moving at, let's say, 700 kilometer per hour, the difference is 300 kilometer per hour. If, let's suppose, E is moving at 400 kilometer per hour, D is 0, the difference in velocities is very high, much higher than between A and B. So because the speed of movement of poles is 0, so that is why the difference in velocities between any region to the poles is always going to be very high. So that is why the bending will be significantly maximum. So that means Coriolis effect is 0 around the region of the poles, and it goes on to become maximum, or Coriolis effect rather is 0 at the region of the equator, and it becomes maximum at the region of the poles. Okay, so that is why in the lower latitude Coriolis effect is comparatively lower. As you keep moving into the higher latitudes closer to the poles, the Coriolis effect keeps on increasing because there's a greater difference in velocity. That is what is referred to as the Coriolis effect. So here, when we talk about it, the Coriolis force in itself, it deflects the winds in the right direction in the northern hemisphere and to the left in the southern hemisphere. Deflection is more when the wind velocity is also high, it adds on to it. It is maximum at the poles and is absent at the equator. Now here, Coriolis force acts perpendicular to the pressure gradient force. What is this? And what is the meaning of this? So let's suppose we are talking about the northern hemisphere. If you have a high pressure in one region, if you have a low pressure in another region. Now the direction of pressure gradient forces between high pressure to low pressure. And if we are talking about the northern hemisphere, the bending will be in the rightward direction, right? So this is your direction of pressure gradient force. And basically, the bending is in rightward direction. So the direction of the Coriolis forces in the rightward direction. So this is your direction of the Coriolis force. The final wind movement will be a resultant of these two. This is the resultant movement. Yes, this will be the same effect in the southern hemisphere as well. That is the resultant movement. So that is why we say that the Coriolis force acts perpendicular to the direction of the pressure gradient force. That is the aspect of Coriolis force. No deviation is happening because here, understand why is it that the deviation is happening? Because the objects are encountering places having different speed. That is why the deviation is happening. Now, around in between 1 and 2, both these places would be moving approximately at the similar speed because both of these places have almost equivalent amount of radius and the equal distance that they travel in one rotation. So, as a consequence, when the objects are moving at the similar speed, there is no deviation between them as we have seen earlier. Hence, at the region of equator, the Coriolis force is almost absent. Okay, so that is basically the aspect of Coriolis force. Now, then we have another factor which influences the wind movement, and that is the frictional force. Frictional force. What is friction? Friction is a force of resistance, always. It opposes the motion. That is your friction. It is the force of resistance. So, if an object, let's say, tries to move in this direction, the friction will apply resistance to it. So, let us have the implementation of it directly with the help of the wind. If I talk about a particular region having various different types of land features and topography, let's suppose you have a lot of trees, buildings, houses, various different aspects. Now, when the wind moves here in this area, the frictional force will be high because there will be a force of resistance which will be offered by the obstacles, the wind, and the trees, the mountains, the various forms of topography. There will be greater amount of resistance. But if the wind is moving, let's say at an altitude of 3 kilometers or 4 kilometers, frictional force will be less. So that means the velocity will be high. That is why whenever you climb up to the higher floors, if ever you live, let's say, in 20th floor, 19th floor, or 33rd floor, or something like that, in a high storied building, you will always experience a greater velocity of wind because the frictional force is less. Whereas on the ground surface, you have the impact where the wind is blocked by the various other buildings, trees, etc. So that is the frictional force, which impacts directly the velocity of the wind. Now, when we talk about the sea surface, over the region of the sea, now there, the movement will be significantly boosted because the frictional force will be less. Because over the sea, you don't have these obstacles in the form of various different trees, buildings, etc. So that is why wind movement over the region of the sea is generally much faster as compared to the wind movement over the region of the land. And also, wind movement at a greater altitude is much higher as compared to the wind movement on the ground surface. So, frictional force affects the speed of the wind. It is greatest at the surface. The frictional force is the greatest at the surface, and its influence generally extends up to an elevation of 1 to 3 kilometers. Beyond that, the amount of frictional force reduces. Over the sea surface, the friction is minimal. Now, from this, basically, can we say that, where can we have a conclusion that in the region of the southern hemisphere, the speed of wind movement is going to be much faster as compared to the speed of wind movement in the northern hemisphere? Will that be a correct assumption to make? Yes. Why? Because in the southern hemisphere is dominated by water bodies, whereas northern hemisphere is dominated by land areas, isn't it? So that is the reason why wind movement wind movement is much stronger over the southern hemisphere. Why? Because dominated by oceans. Now here also we can have a conclusion. Wind movement is much faster in the, or at greater elevations, at a greater height because of lesser frictional force. Now, if the wind speed is high, the amount of bending we have seen is also going to be high. If the wind speed is high, the amount of bending will also be high. We have looked at this. The deflection is more when the wind velocity is high. So that is why in the upper altitude, will be a greater deviation at height. Yes, Chitranshu, that is correct. So that is basically about the various factors which end up influencing the wind movement. Now we'll analyze these factors ever so briefly, but overall, when we take a look at the various different wind movement or the air circulation, just the basic idea of pressure would be more than sufficient. But just to tell you how the kind of questions are framed from there, we can take up a few PYQs for this. So this is one of the PYQs. Take the PYQs and let me know the answer for this. The next set of questions I'll take later on. So, what causes the wind to deflect to the left in the southern hemisphere? Bhavi, no, there is a different reason for that. Yes, Arshad, correct. deflect to the left. Perfect. Good. So, why is it that the wind deflects to the left? It is because of the Coriolis force. And that Coriolis force is because of the rotation of the planet. Rotation of planet. So easy. Okay, this was a PYQ. Well, you can say that to DOPT and UPSC, that this is very easy kind of questions that you are asking. That is why it is for these responses that UPSC has framed the type of question that you see in 2023. Now, should we take another question? Okay, let's take another question. Let's assume that westerly is a kind of a wind. Westerly we have not discussed even though, but let's assume that it is a kind of wind, and let us see if you are able to apply logic. So westerlies in the southern hemispheres are stronger and persistent than the northern hemisphere. Why? Southern hemisphere has less landmass as compared to northern hemisphere. Coriolis force is higher in the southern hemisphere as compared to the northern hemisphere. Why is it that the westerlies are much more stronger in the and persistent in the southern hemisphere? Pressure gradient force is always in comparison. It is not something which is at one particular point itself. Sommelier theory says cyclone cannot form at equator, but however they do. No, they don't form at equator. They never form at equator. We'll come to cyclones, we'll study about that. Hmm. So here there is a confusion. Okay. So here, let's suppose westerlies is a kind of a wind movement. So they are much more stronger and persistent in the northern hemisphere. Why? Southern hemisphere has less landmass as compared to the northern hemisphere. That means frictional force is less. That means speed is high. Okay. Now, so the first statement is correct. Coriolis force is higher in the southern hemisphere as compared to the northern hemisphere. Now, that is not the case. Coriolis force in itself is equally applicable. Now, you might get confused that if the speed is high, so the Coriolis force might be high. But understand the question here. What is the question? The question is westerlies in the southern hemisphere are stronger. That means the winds are stronger. The winds are not stronger because of the Coriolis force. Winds are stronger because of the less frictional force. So that is why you will have this as incorrect. So the answer is going to be A only. So that is just to give you an idea about how the question comes. We take another question here. So this is again something that you have covered. A layer in the atmosphere called the ionosphere facilitates radio communication. Why? The presence of ozone causes the reflection. So this is what I want to tell you in this case as well, guys. All of you who have marked C, you have overthought about this particular portion. Okay, just understand what the question is asking, not what you know, what the question is asking, and reply only to that. That is where majority of the candidates do the error. They start replying to whatever they know. You should only reply or give a response to what is asked. So a layer in the atmosphere called the ionosphere facilitates radio communication. Why? The presence of ozone caused the reflection of radio waves to earth. Radio waves have a very long wavelength. Why is it that the ionosphere facilitates radio communication? Garvit, wrong. No, Gulam, Coriolis force is equal in both the hemispheres. Yes, most of you are correct. No, Yashi, we have not covered westerlies. We will cover westerlies. Hmm. So here, a significant majority of you again have fallen for the trap. This is the trap that UPSC sets, and this is what it expects the candidates to do the mistake. So here, if you analyze individually, the statements. So, a layer in the atmosphere called ionosphere facilitates radio communication. Why is it that ionosphere facilitates radio communication? Because it has got the presence of charged particles. It is the presence of charged particles that reflects them. If the charged particles wouldn't have been present, had the radio waves been long wave or short wave, would there have been a reflection? No. So this is purely because of presence of charged particles, isn't it? Purely because of that reason itself, purely because of the presence of charged particles. So any of the options, do they talk about the presence of charged particles? No. So both the options are incorrect. Okay. So that is where I want you to concentrate. Okay. Let's take another question if we are taking PYQs. The jet aircraft flies or moves very smoothly in the lower stratosphere. What could be the appropriate explanation? There are no clouds of water vapor in the lower stratosphere. There are no vertical winds in the lower stratosphere. Which of the statements given above is or are correct? See, I'll give you the answer that UPSC had given, even though this is a bit contentious. I'll give you the answer which UPSC had given. But all those of you who have marked a different answer, don't worry about it. Garvit, you would be correct, but UPSC actually gave a different answer. And Vivek, Ayush, you are correct in terms of what UPSC had given. So here, ideally, the answer should have been B. That is, there is no vertical wind in the lower stratosphere. That is why you have the kind of a lack of turbulence and the aircraft moves, because there sometimes is there presence of clouds sometimes which are found. But here UPSC said that both of these will be marked correct, and hence UPSC gave the answer C. Okay. So here basically that is the answer. Now let us come back to the discussion again. So when we talk about it, the wind movement is basically classified into onshore and offshore. But sir, there can be clouds in stratosphere as well. Yes, there can be clouds, my dear friend. So some amount of clouds can be there. So the argument of UPSC was that there is no absolute term which was used, which is also a kind of a correct argument. But then the statement always signifies. Now this was asked at a point of time when UPSC did not release a regular answer key. So in order to get the answer, you had people filing RTIs, etc. So here, coming back to it, we talk about the onshore and offshore winds, but there is vertical motion, almost negligible, not there. Okay. Now, what do we mean by onshore and offshore wind? So, whenever there is a wind movement from land to the sea, that is referred to offshore, moving away from the shore. Conversely, whenever there is a wind movement from sea to the land, that is considered to be onshore. So, that represents movement of wind from sea to the land. That is, let's suppose there is a wind movement happening like this. Let's assume there is a wind movement happening like this. Now, this wind movement, or let's assume India itself, let's assume the wind movement is happening like this. Now, if you have this kind of a wind movement, will it be able to cause or create rainfall in the process, or will it not be able to create rainfall? What do you think? Will it be able to cause rainfall? Yes. Why? Because it is able to bring significant amount of moisture. So that is why onshore winds, they carry significant amount of moisture and they are able to bring rainfall. carry significant moisture, bring rains. When we say offshore winds, that is movement of wind from land to the sea. So if there is a wind which is moving, let's suppose like this. Let's assume if there's a wind which is moving like this, that will be offshore. Now, it won't be carrying moisture because it has originated over the land areas. So, land areas are drier. So, that is why it will be a dry wind. So, it won't cause rainfall. So, that is dry wind. So, hence, no rains. Now, this concept of, excuse me, this concept of onshore and offshore wind, that is going to be significantly helpful for you when we talk about the portion of Indian monsoon, when we talk about the global climatic distribution, different types of climatic conditions experienced in different parts of the planet. So that is where this concept will come to your aid significantly. Now, by the way, don't confuse this to the land and the sea breeze. Land and sea breeze that we will talk about again later on in this module itself, that operates over a very small area, only 50 kilometers from the coastline. These are large winds that we are talking about. And large winds in the sense that they move across large distances. And when we talk about movement of winds across large distances, we come across the aspect of air circulation. Now, over the entirety of the planet, you have the air circulation which keeps on happening consistently throughout the year. You have the wind pattern which is observed, and this has traditionally been used by the various different traders, merchants, sailors for hundreds of years in order to navigate through these waters, rough waters, and in order to carry on the trade from one region to another. The sailors and the various different merchants have used this information. But why is it that this air circulation happens? This air circulation happens because, first of all, different parts of the planet, they receive uneven amount of heat. So the lower latitude areas that is closer to the equator, you have the regions which have a heat surplus. Heat surplus. Why? Because they end up receiving more direct rays of the sun, and the amount of solar insolation is consistently going to be high. Be it the summer, the winter, the amount of insolation is significant. Whereas when we talk about the higher latitude regions, these are going to be heat deficit areas. Heat deficit areas. So this impacts the air pressure as well, and that can induce a circulation pattern. Now, the role of this air circulation is very significant. This air circulation, if it would not have been present, then these heat surplus areas would have continued to get heated, the temperature would have continued to rise, and it would be very, very hot, 100 degrees Celsius, maybe even more. And these colder areas which do not receive significant amount of heat, these would have continued to be very, very cold. So air circulation helps regulate the temperature and distribution of temperature or heat from lower to higher latitudes. Okay. They help in circulation of that heat, regulation of heat, distribution of heat from the surplus regions to the deficit areas. Because whichever season you consider, be it the winter season or the summer season, be it the northern hemisphere tilted towards the sun or the southern hemisphere tilted towards the sun, on an average taken throughout the year, always you will find that the lower latitude on an average would have received greater amount of heat due to greater angle of insolation, whereas the higher latitudes they would have been colder. Now, for a long period of time, that is throughout almost for the past millennia or so, all the records about the wind movement were basically dependent upon the sailors. The sailors and the merchants, as they would go from one region to another, they would report the wind movement. That as we traveled from this region to this region, initially the wind movement was like that. Then came a region of abnormally calm conditions. Then came a region of again this kind of a wind movement. So you had these records which were kept. Now, based upon that analysis, an air circulation model was floated, and that was floated by Hadley, and that was referred to as a kind of a Hadley circulation or a unicirculation model or a unicell circulation. So this is basically what is referred to as unicellular model of circulation. This was provided by Hadley. And Hadley based this kind of circulation aspect purely on temperature. Circulation purely because of temperature. Now, what was Hadley's assumption, or what is it based upon which Hadley gave this theory? He said that look, the lower latitude, the equatorial regions, they are going to be very hot. So, because they are going to be very hot, they will end up creating a region of low pressure in the lower latitude. And the region of the highest latitude, that is closer to the polar region, they are always very cold. So, they will end up creating a condition of a high pressure. Winds on the surface will always blow from a high to a low. So winds will be blowing from a high pressure to a low pressure. The winds will come to the low pressure, they will get heated up, they would rise up. Here they would rise up into the upper atmosphere, and then the circulation would be completed. That was Hadley's model. So, as per Hadley's circulation model, on the surface, the winds would consistently be blowing from the region of the poles to the region of the equator, whereas in the upper atmosphere, there will be a completion of the cell where in the upper atmosphere, the winds would be moving from the region of equator to the region of the poles. That was his assumption and that was his postulation. Now, it did exist, this theory did prevail for significant proportion of time, but after some time, based upon the various different understandings and more explorations of the planet, it was understood that look, any wind which originates from the region of the poles, it can never be so powerful that it will reach the region of equator, because there will be bending as well, significant amount of bending as well. Even when we talk about the upper atmosphere, where Hadley propounded that look, the winds will originate from the region of equator and they will continue to move to the region of the poles. So in the upper atmosphere also there will be Coriolis force and the bending. So that will never allow the wind to reach the poles at all. And on the surface there will be so much amount of frictional force that the winds will never be able to reach the equator. So it was later upon when the understanding of Coriolis force, etc., that was understood in the 1800s, in the mid 1800s. It was understood that there can never be a wind which can originate from the region of the poles and can reach the region of equator. Similarly, there can never be a wind which can in the upper atmosphere which will move from the region of equator and can reach the region of the poles, because the winds will get deviated, and they will get deviated in such a way that they will never be able to reach the poles at all. Because let's understand, or let's assume the upper air circulation, if a wind is moving or originating from the region of equator, they will be bending to the right. As they bend to the right, They will never be able to reach the region of the poles. Regardless of how strong the wind is, it will never be able to reach the region of the poles. It will accumulate in some particular area. So that is why this unicellular model was actually discarded. It was trashed. And then what was understood was the modern method of air circulation. Even that has been modified ever so slightly. But for your general studies, even this modern method is more than sufficient. And that is what was referred to as the tricellular model of atmospheric circulation. Cellular model of atmospheric circulation. Okay, the tricellular model of air circulation. Now, what is this? So, understand this basic property. Once you understand this basic, and I hope you revise it sufficient number of times, then almost all the various different climatology aspects, including the temperature distribution, including the aspect of the weather pattern, everything will come naturally to you. So here we take the case of the northern hemisphere. It is exactly similar when we talk about the southern hemisphere. Not exactly, but almost similar. So let's assume this is equator, 0 degree. Let's assume this is 30 degree north. Or if it confuses you, why only 30 degree? Why not 29? Why not 31? Is it pre-decided by Almighty being, etc.? So let's assume 25 degree to 35 degree north. Then let's assume you have 55 degree to 65 degree north. And let's assume this is 90 degree. Okay. Now, how is it that the air circulation happens, or how is it that the air continues to move? First of all, we concentrate upon the region of equator, around the region of 0 degree. Now, around the region of 0 degree, what will be the temperature? Temperature will be significantly higher. It will get heated up, isn't it? Now, when the air gets heated up, it will start rising, because when the air gets heated up, it gets lighter. Anything which is lighter will rise up. As long as it is warmer than the surrounding air, will continue to rise up. Now, as the air here rises up, that means here you have a creation of a high pressure or a low pressure. A low pressure rising air is always associated with low pressure. So that means it would attract winds from the surrounding regions. So winds will come from the surrounding regions. And these winds, when they come over this region, they would also get heated up. They would also start rising up. Now here the winds are rising up. Now they will rise up till what level? Up till the region of tropopause, not beyond that. They would be rising up to the level of tropopause. Once they hit the tropopause, they will diverge after that. One goes towards the southern hemisphere, other goes towards the region of the northern hemisphere. Now, as here we are talking about the region of very high altitude, at the region of the tropopause. So what will be the wind velocity in this area? Wind velocity in the region of tropopause, there it will be high or low? It will be very high. Why? Because the frictional force is very less. So when the wind velocity is high, then the deviation will also be significant. So let us assume the upper air movement. With this image, let us assume the upper air movement. This will only reflect the upper air movement, not the surface. Upper air. So the wind has actually, if we consider the northern hemisphere, wind has originated from the region of equator in the upper atmosphere. It is moving northwards. It is moving northwards towards the region of the poles. It will deviate to the right. Now, because the speed is very high, deviation will be significant. Will it be able to reach the region of the poles? No. The wind will try to or start accumulating somewhere around this particular stretch. There will be an accumulation of the wind. There will be accumulation of the wind. More and more wind will be piled up because more wind is rising up due to heating of the surface. So more wind will be piling up around this area. And at this area, at this region, as there is more wind which is piling up, by the way, what will be the temperature of air at this region? The temperature of air will be low because we are talking about many kilometers from the Earth's surface. So the temperature of wind will be low. So that means the wind is cold. The wind is piling up as well. So the wind in this area, in this region, because it becomes cold, the air starts to sink. The air indicates a sinking motion. Now, upon hitting the ground surface, the air will diverge. One will go towards the region to fulfill the vacancy created at the region of equator due to heating. The other portion will go towards the region of the poles. Meanwhile, in the region of the poles, what will be the temperature? Very, very low. The region of the poles are always going to be very cold. So that is where you will always experience a sinking air. Here you will always experience a sinking air. And that air, upon hitting the ground surface, will move here. So in this region, you will have what? A high pressure. In this region, you had what? A low pressure. In this region, what will be there? High pressure or low pressure? Around 25 to 35 degree. Will it be a high pressure or a low pressure? A high pressure because you have sinking. Now, there is a wind which is coming from the region of the poles. There is a wind which is coming from the region of the tropics. They will come. They will collide. They will have no other place but to be pushed up. So this wind then rises up. Okay. It will rise up. Then one portion will come here, further add on to the surplus which was created. And there is a kind of a convergence collision in the upper atmosphere. So this wind has got no other place to go, but it will start to sink. Whereas this one will continue to move and fulfill the sinking air around the region of the poles. Isn't it? So here, what do you observe? You observe the creation of a air circulation with the creation of three different cells. Isn't it? You have the creation of three different cells, hence the name tricellular model of circulation. What will be the condition of pressure here? Here you will have low pressure. Now, if I ask you what kind of pressure is created, now in the region of equator, will you have a thermal low pressure or will you have a dynamic low pressure? Because all of us agree that there will be low pressure. So here, when we talk about the thermal low pressure or a dynamic low pressure, a thermal low pressure, perfect, because it is because of heating that the air is rising here. So you have thermal pressure zones, right? And what is the condition at 90 degree? Will it be a thermal low pressure or a dynamic pressure? When we talk about 90 degree, will it be thermal or dynamic? Why is that high pressure created at 90 degree? Why? Because of cold conditions. So when it is a cold condition, that is why you have sinking of air. And because it is a cold condition creating that sinking of air, so it will always be a thermal low pressure, a thermal high pressure. So you have two thermal pressure zones at the region of the poles and around equator. And when we talk about the dynamic pressure zones, what are the dynamic pressure zones? So at 30 degree, you have a thermal low high pressure or a dynamic high pressure at 30 degree. Dynamic, because it is a sinking of air which has created that high pressure. What about 60 degree? Despite the cold temperature, 60 degree has got low pressure. And at 30 degree, despite the high temperature, it has got high pressure. So it is dynamic. So that is 30 degree and 60 degrees. Right? Same is the case in the southern hemisphere as well. This is what is referred to as the subtropical high pressure belt. Subtropical high pressure zone, which is created due to dynamic conditions because of collision of air. This is what is referred to as the subpolar low pressure belt. Low pressure zone, because it is created due to dynamic low pressure, because the winds are converging, it has got no place to go. Despite the low temperature, the winds are pushed up, and whenever you have rising air, that will create low pressure. This will have a kind of a, this is what are referred to as polar highs. This is a dynamic pressure zone. This is a thermal pressure zone, and this is what is referred to as equatorial low. I will repeat the entire process again, so don't worry about it. I will repeat the entire process here. So when we talk about the air circulation is always impacted by the, and listen to this carefully, guys. Air circulation is always impacted because of the creation of different pressure. We have seen that for the air movement to happen, there is only one simple principle, that air will move from a high to a low. That is from a region of a high pressure to a region of a low pressure. Now understand the region around equator. Around the region of equator, there will be significant amount of heating. So as there is a significant amount of heating, the air will get heated up. Once the air gets heated up, the air starts to rise up. As the air starts to rise up around the region of equator, it will create a vacancy of sorts near the ground surface. So that would attract winds from the surrounding region, right? Winds from the surrounding region, from the tropics, the winds will come, and then they will again get heated up because the heating is continuous. So they will also rise up. More winds will come, more will get heated up, more will rise up, further more winds will come. So this process continues. Now the winds get risen up till what? Up till the region of troposphere. So as they reach the region of troposphere, after that, the winds will diverge. After hitting the troposphere or after reaching the tropopause, the winds will diverge. One moves in the southern hemisphere, one portion moves in the northern hemisphere. Now, as they are moving in the northern hemisphere in the upper air, now this wind movement here, this wind movement in the upper atmosphere that you see, this will, this cannot go to the region of the poles, never, even though they are moving towards the poles. But this wind will be, if I say the upper air, so the upper air wind movement will have significant speed. They will bend due to Coriolis force in the rightward direction. So as they bend, all that air keeps on accumulating here in this particular stretch around 25 to 30, 35 degrees, almost around 30 degrees. The winds will keep on accumulating, and further they will converge with another wind coming from the region of 60 degrees. So as they converge, the winds have no other place to go but to sink down. So as they start sinking, they will hit the ground surface. So when they hit the ground surface, they will always increase the pressure. So despite the fact that at 30 degrees you have higher temperature, there will be a high pressure. That is a dynamic high pressure. Now, upon hitting the ground surface, the winds will diverge. One will go to fulfill the vacancy at equator, other will go towards the region of the poles. Now, at the region of the poles, you already have a sinking air. Because of very cold conditions, you have a sinking air. So that sinking air will hit the ground, create a thermal high pressure at the region of the poles, and from there it will move towards the lower latitudes. After hitting the ground, it where will it go? After hitting the ground, it will always go towards the lower latitudes. So as it moves, it collides with the wind coming from the tropics, and the winds, they collide, they have no other place to go but then to be pushed up. So whenever you have rising air, that creates what? Low pressure. But this is created not because of temperature. This low pressure is not because of temperature. This is because of the collision of the air. So you have a dynamic low pressure created at 60 degree. You have a dynamic high pressure created at 30 degree. Now here it rises up. Again, it will hit the region of tropopause. It will diverge. So that is how it ends up creating the case of movements or the formation of these cells of circulation. This is what is referred to as the Hadley cell. This is what is referred to as the polar cell. Now, Hadley and polar cells, they are controlled by the temperature factor. Temperature factor at the region of equator, temperature factor at the region of the poles, they become the drivers of the Hadley and the polar cell. But when we talk about the between the in middle one, now, this one has purely come into existence as a kind of a gear mechanism. In the case of a gear, what do you have? Two wheels move, and in between them, any pulley or anything that also ends up moving. So, this circulation, which is referred to as the Ferrel cell, that is created purely by the dynamic pressure. Okay. Now, furthermore, when we talk about the region of the low pressure or the equatorial low, now, at this region of equatorial low, you have winds which are coming from which region? From the tropics. Both in the northern and the southern hemisphere, the winds are coming from the tropics, isn't it? So, this is where it is referred to as the or the winds are coming from the tropics. So, hence, this is referred to as intertropical convergence zone. Intertropical convergence zone, or what is also named as famously ITCZ. Okay, that is what is referred to as ITCZ. So, this creates on the surface a kind of a continuous wind movement throughout the year. Across the planet, this wind movement is created. So, on the surface, the wind movement which is created, that is what is referred to as the permanent wind system, because they are existent across the planet and they are existent throughout the year. Whereas, when we talk about the pressure zones which are created, they are the ones which will initiate or impact the wind movement. Now, when you have the summer in the northern hemisphere, let's say you have summer in the northern hemisphere. So, the greatest amount of heating will be received somewhere to the north of 0 degrees, somewhere maybe here, there will be significant amount of heating. So, when you have summer in the northern hemisphere, the ITCZ will shift slightly to the north. So, if the ITCZ shifts north, what will happen to the subtropical high pressure belt? It will also shift north because of the Hadley cell. So, the subtropical low pressure belt will also shift slightly to the north. But the polar high will remain where it is because that is going to be the coldest region. That means whichever region around the region of equator is going to be the hottest, the absolute low pressure, that is where the ITCZ will lie. Okay, so ITCZ always ends up representing roughly the absolute low pressure around the region of equator. That is why it is also sometimes referred to as the thermal equator. Now, when let's suppose there is significant amount of heating in the southern hemisphere, that is winter in the northern hemisphere and summer in the southern hemisphere. So that means the southern hemisphere will get more heated as compared to northern hemisphere. So the ITCZ will shift somewhere here in the southern hemisphere. So all the pressure belts will shift slightly to the south. Okay, so the pressure belts, they shift north during the northern summers, and they will shift to the south during the southern summers. That is the shifting of the pressure belts. Okay, so let us take a look at these pressure zones and also the kind of wind pattern that they create on the ground surface. So this is your condition of atmospheric circulation. So here, if you observe, this is your equatorial low. This is also what is the ITCZ. Why? Because it is here that winds from both the tropics, they come to this region, and winds from both the tropics, they are converging here, hence the name ITCZ. Here you have a high pressure created by the sinking wind. Here again you have a low pressure, that is a dynamic low. So that is what you have as the tricellular circulation. Okay. Now, when we talk about the wind movement on the surface, when we talk about the wind movement at the surface, some wind return to equator and some wind are going to the poles, because when the winds hit the ground, do or will all the winds after hitting the ground move only in one direction? As the winds hit the ground, remember what we studied in the case of the dynamic pressure belt. So dynamic pressure and the thermal pressure zone, so as the winds will hit the ground, they will diverge in both the directions. So that is why one goes towards the region of equator, one goes to the region of the poles. So here, when we talk about, let's say, these wind movements, let us consider the ITCZ. Let us consider the subtropical high pressure, subpolar low pressure, let's consider around 55-60 degrees, and then the poles. Now let's try to understand the wind pattern and the wind movement. Now on the surface, you have the winds which are going to move from 30 degree to the region of ITCZ in both the hemispheres on the surface. So that means on the surface, the winds are going to move in this direction in both the hemisphere, but they are going to bend, isn't it? So they are going to bend because of the Coriolis impact. So that is why here you will have the bending. Why do they decrease in height? Apply your logic. Why would they decrease in height? So did you think this was a kind of an incorrect image that I drew? I could also have drawn a straight line. Apply your logic. We have studied that why the height has reduced. That is because the height of troposphere is highest around the region of equator. It decreases around the region of the poles. We have talked about that, isn't it? So here the wind movement will bend to the left. Right? So that is the kind of a movement that you will observe there. Then, furthermore, if we talk about the wind movement between 30 degrees and 60 degrees, so the wind movement happens between the region of 30 degrees to 60 degrees. Wind is consistently moving from 30 degrees to 60 degrees. So here the wind movement will be from here to here, but they will be bending to the right and left. So in the northern hemisphere, the winds will move like this. In the southern hemisphere, the winds will be bending to the left. Now, furthermore, between 60 degree to, let's say, 90 degree. So between 60 degree to 90 degree, we have seen that the wind movement is from pole to the 60 degree. That is where the collision or the convergence is happening. So here the wind movement will be like this. Here the wind movement will be like this, but it will bend. So what do you have? You have the wind movement like this. Here you have wind movement like this. Now, The winds, when it comes to the naming of the winds, winds are always named based upon the region or the direction from where they originate. Always. The naming of the winds is always done based upon the direction or the region where they originate. So that is why when we talk about, for example, these areas from the region of 90 degree to 60 degree. Now, in this area, here, what do you observe? You will observe that these are the polar winds, and overall they are moving from east to west. So these are also what are referred to as polar easterlies. Okay, these are your polar easterlies. Southern Y left. Did you join the session late, my dear friend? For the first 45 minutes, we have invested our time in this aspect as well, itself. That why right in the northern hemisphere, why left in the southern hemisphere? It is because of the Coriolis force. Okay. Now, furthermore, here, because both are easterlies, because both observe they are moving from east to west. Now, then after that, here they are in a way moving from west to east, right? These are moving from west to east, be it in the northern or the southern hemisphere. These are what are referred to as westerlies. These are referred to as westerlies. Now, here, these are referred to as the northeastern winds and the southeastern winds, because if you observe their direction, northeast to southwest in the northern hemisphere and southeast to northwest in the in the southern hemisphere. But then typically they have been utilized by various different merchants, sailors, traders, etc., to carry out the trading purposes. So that is why these are what are referred to as trade winds. Trade winds. Or if you want to be specific, this is what is referred to as northeastern trades, northeastern trade winds, or simply northeastern trades. And these are referred to as southeastern trade winds because that is the direction from which they are originating. Now, all these winds that we have talked about, they end up moving through the entirety of the planet, and they end up existing across the entirety of the year. So that is why these are also what are referred to as the permanent wind systems. Permanent wind systems. Okay. Now, when we talk about the pressure belts, so all these winds, they will end up creating or they will end up moving between the different pressure zones. They will end up moving between the different pressure areas. So you have the ITCZ here. Now, the ITCZ is also what is referred to as the region of doldrums. Why? Because at this exact point of ITCZ, not much of a wind is observed. How? Just now we have seen so much amount of wind movement. So how is it that we can say that no wind movement is observed? So understand that and understand the larger aspect of it. So suppose this is the entire region of ITCZ, suppose. Now, as the winds are coming here, the winds, they get heated up over this entire region. Over this entire area, the winds get heated up and they start rising up, isn't it? So as the air comes here, the air over a period of time, the air will get heated up in this region and then it will rise up, creating a vacancy. Now, if you were an individual standing here, you would experience a wind movement. If you were an individual standing here, you would experience a wind movement. But what if you are an individual who is standing absolutely at the middle of it? You wouldn't experience any horizontal wind movement at all. So you would not even feel that the wind is rising up. So, because at this particular point you don't experience any wind movement, that is why. And these are the things that the names have been given since ancient times, or since the Middle Ages, when you had the sailors, travelers, etc., moving through here. So, that is why, because of the lack of wind movement, this was referred to as, or this is referred to as, the ITC set, or the doldrum rather. So, lack of wind movement. In the sense, horizontal wind movement. So, significant horizontal wind movement will not be observed. Horizontal wind movement. Only vertical rise of air will happen there. And that is, so if, let's suppose, imagine yourself in those ages commandeering a ship or being a captain of a ship, you would not be able to move anywhere. Vertical air rise of air will not help your ship to move anywhere, because in those days the ships basically would move through the help of the wind and the sails that they had, so they would not be able to move anywhere at all. So that is why it would be referred to as the region of the doldrums. Then this is an area at 30 degrees roughly, that is what is also referred to as the horse latitudes. And here also you have an anecdotal story because of it, but understand the aspect here also very similar to that of doldrums. So if you are at 30 degrees, now you will have wind which is coming here, sinking, hitting the closer to the surface and then diverging. So again, if let's say you were an individual here, or you were an individual here, you would have experienced a wind movement. But what if you are an individual standing here? Would you experience any horizontal wind movement? Not at all. There is a sinking air. So, whenever the sailors and the ships would come to this area, their ship would get stuck in the region. They would never be able to move for a longer period of time. And in those days, in the older days, the traders, the sailors, they would always travel with a lot of horses as well. Because once they would reach the land, it would be these horses which they would use to move from one region to another. So they would generally travel with a lot of horses. Now, these horses would consume their own set of resources, the food, the water, etc. Many of the times, the ships would get stuck here for many days altogether, leaving a kind of a water scarcity, significant amount of water scarcity. So that is why what people would do is, the sailors, what they would do is, they would push the horses into the water, and the horses would be pushed into the water, so that first of all there is saving of the resources, and also there is enough amount of turbulence created in the water so that the ship gets some amount of movement, and after that maybe the wind could help it up. So that is why, because the horses would be thrown overboard in this region, and to conserve the resources and to provide some kind of a movement, hence the name has stuck and continued. That is why this region of calm conditions is also referred to as horse latitude. In both these areas, you will not observe horizontal wind movement. Lack of horizontal wind movement. Horses would not help in wind movement, my dear friend. But if you throw, let's say you throw a stone in water, it creates certain ripples. So if you have many of these stones that, or many of these horses that you throw, it will create some ripples. So maybe some impact on the movement itself. So that is the subtropical high pressure belt. This is your subtropical high pressure belt. High pressure zone. Yes, the horses cannot swim. It was not to help the horses or to save the horses. It was to kill the horses, because that is how you conserve the resources. Okay. They should have thrown rocks, but where would they get the rocks in the middle of the ocean? How is it that they would have gotten the rocks from in the middle of the ocean? That is why whatever would be available, they would throw it. Okay. So that is basically the condition of the pressure zones. So reflect upon it, think upon it, we take a break, and then after that, we come back again and we carry out the aspect. I'll show you what happens in reality. In real world scenario, you don't have the entire region as a uniform pressure belt. In reality, you have pressure pockets. And without going into the modern theory about it, I just want you to understand that what happens in reality, so that you are also aware about it, even though that is not very much relevant for your general studies portion. But still, I want you to be aware that how is it that the pressure patterns behave in the real world scenario, in the summer months, in the winter months. Okay. So why they are called permanent winds? Because they are persistent throughout the year, and they are persistent across the entirety of the planet. So I'll leave you to this particular slide, right? Digest it, and then after the break, you come back and we continue. So we take a break, we come back at 7. Okay, take a break, digest this, and then be back. A confirmation about the audio, please. If the audio is clear and available, thank you. Sayashri, yes, I am getting this message that you have posted, but then the question I have not gotten. So now, at tropical high pressure zone, will wind first not touch the ground surface and then diverge? It is not exactly going to touch the ground surface. It is basically because, please understand, on the ground surface also you will have some air which is already existent. It is not as if it is a constant vacuum. So that is where it will add on to the pressure on the ground surface and it will start diverging closer to the ground surface. Okay. But nonetheless, whether even if it touches the ground or not, or at this exact point where the air is sinking, you will not have any kind of horizontal wind movement which you will experience. Okay. Right. So why tilted axis is not considered? Tilted axis is considered, but the thing is that if you consider a long term annual average, then this tilted axis basically averages itself out. That always the polar region, regardless of whether it is the northern portion which is tilted or the southern portion is tilted, over a long period of average of 1 year, you will always have the higher temperature at lower latitude and lower temperature at the higher latitude. So that is why the annual average is considered. And Gulam, vertical and horizontal point. What vertical and horizontal point? Are you talking about the horizontal movement of the wind? So in this particular portion, you don't experience horizontal wind movement. Here you will experience horizontal wind movement. Here you will experience horizontal wind movement. Okay. ITCZ and the doldrums are the same. What are the shrieking 60s and the furious 50s? So basically what you have is that in the when we talk about the westerlies in the southern hemisphere are much more stronger as compared to the northern hemisphere. In the northern hemisphere, because you have significant amount of land mass, there is a greater amount of frictional force as well, so the westerlies are not very strong. But in the southern hemisphere, because it is around the region of the westerlies, the southern hemisphere is completely covered with water, oceanic areas. So that is where the wind movement is very fast. And that is why, as the wind movement is very fast, it creates that particular kind of a sound. So you would also have observed when the wind is very fast, then you have some amount of sound that is created. That is why it is furious 40s and then shrieking 60s and so on. Horse latitude will also be referred to as a horse latitude. The 30 degrees south or the subtropical high pressure in the south will also be referred to as the horse latitude. If wind velocity is high, then how come Coriolis force is high? Because the speed difference will reduce. No, the speed difference, why will it reduce? The speed difference is basically between the different latitudes that we are talking about. So that speed difference will be further exaggerated if you, let's suppose you throw the ball. Now, if you throw the ball with a great velocity, there will be a greater amount of divergence or deviation, because by that point of time, let's say the object would have moved further ahead or would have been left further behind. Okay. And Pooja, there have been certain issues with the change of vendor. That is why, and I would suggest to you that that I have been suggesting from day one itself that you can start studying from the NCRTs itself. NCRTs which are freely available. That is something which will help you. And these will be the basic books for geography. As far as geography is concerned, it will be more than sufficient. Okay, and horses would die after pushing them in sea. Yes, horses would be killed and then would be pushed into the sea. And Gaurav, I don't understand why 60-degree experience low pressure. It is not because of temperature that, see, 60 degrees is a dynamic low pressure. That is because you have air coming from poles, air coming from the tropics. Both of them, when they will collide, they will be pushed up. There is no other aspect or there is no other region where they can go. So as the wind is pushed up, so on the ground surface, what will be the impact of pressure? If there is a rising air, that will always experience a low pressure, isn't it? Why ITCZ is referred to as doldrums? Because it is referred to as a kind of a lack of horizontal wind movement. Whenever you are in this region, there won't be significant amount of horizontal wind movement. Hence, okay. The presence of extremely low temperature through the year at polar high pressure. Ragini, that is because the poles are always very cold. Because that is what we have discussed about the angle of insolation. We have discussed about the difference in temperature. So, temperature in the higher latitude is always going to be lower because the solar rays are always going to come at an inclination. You will never have the sun at a vertical condition that you observe in these areas, or let's suppose whichever area that you are living in. So at around 1 o'clock, 12 o'clock, 2 o'clock, you will find that the sun is almost vertically upwards. So that is when you receive much amount of heat. But in the polar region, the sun is always at a slanting position. Okay. Nazarka dynamic pressure we have covered in the previous session itself. Why horses are thrown? In order to conserve the resources, horses used to be thrown, not now. We are talking about the earlier times when the ships would be moving only by the aid of the wind movement. Now you have the ships being able to move through the various different aspects, such as, let's say, the diesel propelled engines, or let's suppose in certain cases nuclear powered engines. Earlier you did not have those facilities and those technologies, so they would completely be reliant upon the wind movement. And when you did not have enough wind, the resources would start getting emptied, and more significantly, water would be a very scarce resource. So that is why, the in order to conserve them, and also when you throw the horses, it would create some amount of ripple in the water, some amount of disturbance in the water, and with that, the ships would end up moving ever so slightly. So if there is a slight movement, maybe the further movement will be carried out by very slow moving air, etc. So that would aid in the movement. Okay. High pressure at the tropics are due to the sinking air. Yes. No, Chitranshu, no such name. Offshore and onshore, they don't affect the Hadley circulation. It is these trade winds, westerlies, etc. They will be offshore in certain areas, they will be onshore in certain other regions. What are the objects in Coriolis force? The wind, for example, wind movement, oceanic circulation, airplanes when they move, missile movements, rocket movements, any of these you consider that as objects. Mahesha, 30-degree, why high pressure? This also there is sunlight. Because it is not a thermal high pressure, it is a dynamic high pressure. So at 30-degree, it is not a high pressure because of low temperature. It is because the air is sinking. So despite the high temperature, because the air is sinking, so when the air is sinking on the ground, it will always increase the atmospheric pressure on the ground. Okay. Now, when we talk about the real terms and the practical scenario that you experience on the ground, so on the ground, you will never experience a continuation or a continuous presence of this low pressure belt or a high pressure belt spreading just like what you see in the image. In reality, what you have is you have certain pockets where there is heating and creation of equatorial low, and certain pockets where there is a sinking of air and creation of a subtropical high pressure belt. So that is where, if you observe these pressure zones, rather than pressure belts, you have the creation of a pressure zone. So observe here, you'll find the low pressure here. This is the ITCZ. Now this is in the month of January. So January means it is summer in the southern hemisphere, right? Southern hemisphere experiences summer. So there will be greater heating of the southern hemisphere. So observe here, you will have the low pressure, that is your variation of ITC. And then observe the high pressure areas. These are your high pressure areas. These are your subtropical high pressure zones. This is the subtropical high pressure, right? Then you have, these are your subtropical high pressure. Then you have the subpolar low pressure here. Okay, subpolar low pressure. This is what is also referred to as Aleutian low. Because of the Aleutian Islands, that is where you have significant amount of this dynamic low pressure, hence the Aleutian low, Icelandic low, right? These are your low pressure, subpolar low pressure. This is what is Azores high. Okay. Now, in the month of July, that is when you have the summer in the northern hemisphere. So, in the month of July, if you will observe, when you have summer in the northern hemisphere, look, this is the ITCZ. Now, as the land areas would get more heated up, the ITCZ also ends up moving significantly northwards. It bends northwards. This is what is the Bermuda high or the Azores high. This is what is referred to as the Hawaiian high, right? And here you have the high pressure, the subtropical high pressure, the dynamic high pressure. Okay, this is where you have the subpolar low pressure. Okay, so this is basically how the pressure zones actually are present, and how this is where you will have the wind movement. So this is where you will experience a kind of a continuous wind movement. For example, wind will move from here to here and so on. Okay, so that is what drives the various different types of wind movement and wind patterns. Now we come to the portion of local winds. So we have earlier seen that, or we have just now seen the presence of permanent winds. And they are referred to as permanent winds because throughout the year, these winds basically they end up moving, and these winds cover the entirety of the planet. So when we talk about the permanent winds, why are they referred to as permanent? Is because of these two factors: move throughout the year or move across the planet, are in existence throughout the year. Now you have some winds which are present only in certain sections of the world, and they are only present for some season or for some certain time duration. Now these winds, for example, take the case of Lu. Now Lu is observed only over India and Pakistan, northern part of India and Pakistan. Similarly, you have, let's suppose, land breeze, mountain breeze, valley breeze, sea breeze. Now, these are not going to be felt across the entirety of the planet. So, you have these localized winds which exist over only a short region, or small region, or only for a certain time of the year in some part of the planet. So, those kinds of winds which are localized for either some part of the year or in some part of the planet, that is what is referred to as local winds. So here they are winds which are present for a certain specific season and also for a certain area. Okay, so they are referred to as local winds. Now these local winds can be characterized as seasonal winds and the daily occurrence of these winds as well. So here you have basically the seasonal winds and you have daily winds. So in the case of the seasonal winds, you have various examples such as Chinook, Lu, Typhoon, Mistral, and the list goes on. Whereas when we talk about the daily localized winds, which end up reversing their direction on a daily basis, changing their direction on a daily basis, so they change their direction on a daily basis. Direction and movement on a daily basis. So that is where you can have the example of land and sea breeze, mountain and valley breeze. Okay. So that is basically these daily localized winds. So let us take a look at each one of them. We'll start with these daily localized winds, and we start with the aspect of the land and sea breeze. Now these are basically experienced only over a short area of the coastline. Overall, if you take a look at it, the entire span of these winds, they will be not more than 50 kilometers. So that means a very short and a small area. Now, why do they get created? They get created because of the pressure difference which exists due to the variation in temperature. So get created due to pressure difference impacted by temperature. So here, if we take the example here for suppose during the daytime, suppose when we consider the daytime, now we have already seen that during the day, it is the land which will get significantly warmer, right? Sea is comparatively cooler as compared to the land during the day. So when the land gets significantly hotter during the day, here, as it gets hotter, you will have creation of a low pressure. In comparison, the water which is cooler, that will create a comparative high pressure. Winds will always blow from a high to a low. So the winds will blow from here. These winds will carry significant amount of moisture as well. And then upon reaching the low pressure areas or the heated areas, they will also get heated up, rise up. They can end up forming clouds, bring rainfall, etc. So because this kind of wind originates over the region of the sea and then comes over the land area, as I told you, the breezes or the winds, they are named after the region where they originate or the direction where they originate. So because it is originating over the sea, hence it is referred to as sea breeze. That is experienced during the day. Experienced during day. Okay, that is what is referred to as a sea breeze. Now during night, what happens? We have seen earlier in the previous module that at night, it is the land which gets colder. The water is comparatively warmer because land loses heat much quickly and water takes its own good time to lose heat. So that is why over the region of the water, you will have the creation of low pressure because the water is comparatively warmer, and land which has gotten cold, that is where you have a comparative high pressure. So that is why the winds this time will originate from the land and will move over to the sea. Because it has originated from the land, hence it is referred to as land breeze. This is during the night. Now, because this happens on a daily basis, on an everyday basis. That is why you will experience that there is a moderation in temperature every day during the daytime. That is why whenever you go to the coastal area, if you live in a coastal area, then you would experience it on a daily basis. But across the coastal area, when you go during the day, you will experience very cool breeze coming from the sea to the land. And during the night, you will experience the opposite. It is not as if the wind will be coming from the sea. You will experience the wind coming from your back and moving towards the sea. That is your land breeze. Both of them, they consistently are present across the day, and during the day you will experience sea breeze, during the night you will experience land breeze, and that is where the moderation of temperature does happen. It is driven by the simple conditions of thermal or thermally induced pressure. So this is created purely because of thermally induced localized pressure. Thermally induced localized pressure. Okay, that is your land and sea breeze. Now, this daily reversal of wind is also something which is observed in the mountain and the valley regions. And that is because of the differential amount of heating and cooling which happens. And that creates various different conditions of pressure as well. For example, when we consider the region of a mountain or a hill in general, now during the day, we do know that when we talk about during the day, now, during the day, we do know that the amount of insolation is much higher as you go higher up in altitude. So, the amount of insolation is higher. That creates a low pressure, significant heating. So, that induces a kind of a low pressure here. And during the day, in comparison, the amount of insolation received on the ground is comparatively lesser as compared to that of a higher altitude. When we were taking a look at the factors which end up determining the variation in insolation, if you recall, we looked at four different conditions and four different factors. One of them was altitude as well. So that altitude ends up impacting the amount of insolation. So at the ground surface, at the sea level, you have lesser insolation. At a greater altitude, you have higher insolation. So due to that, during the day, you have low pressure created on the top. So this attracts winds, and the winds, they start to move from the valley to the mountain top during the day. And because they have originated over the region of the valley and moving towards the top of the mountain, hence they are also what are referred to as valley breeze. Because that is where they have actually originated from. And then what happens during the night? During the night, both of them or will lose heat. But when we talk about the topmost portion will lose heat much quicker. It will be very, very cold. So as the mountain top becomes very, very cold during the night, so this will be a region of high pressure. Perfect. What we also saw in the case of valley inversion, something very similar. So here you will have high pressure. Comparatively, the valley bottoms will have a kind of a low pressure because warmer air at the valley bottom in comparison. So you have winds moving from the mountain top to the valley. From the mountain top to the valley. This is experienced during the night. And because here the wind is originating from the mountain top, that is why it is referred to as mountain breeze. That is what we have as the mountain breeze. Okay. Garvit, in temperature inversion chapter, you said in bracket, as far as I remember, mountain top is cooler because, so in the temperature inversion chapter, if you recall correctly, Remember the case of valley inversion, and I have told you that it happens during the night. I have never said that the valley inversion is prevalent throughout the day. If you look at even the annotations of the PPT, I've written there that it happens during the night, because it is at night when the mountain top loses heat very quickly, and that is when it becomes very cold, and it ends up creating a kind of a high pressure. And that is why during the night you have the mountain breeze, whereas during the day you have the creation of a valley breeze. Now we come over to the seasonal winds, the seasonal localized winds. So we start with our very own, that is Lu. Lu is something which is experienced in the region of Pakistan, in the region of northern portion of India. So that is above the region of Tropic of Cancer. Now these are the localized winds which are created because of extreme heating of land throughout the summer season. And during the summer season, when the land gets significantly heated up, there is creation of localized areas of low pressure. So this attracts winds, and the winds generally they move from the region of Pakistan, and after they cross the Thar desert in Rajasthan, these winds they become very dry and further warmer. But because there is a low pressure created, these winds further end up moving across the region of the northern plains. And when they move generally in the later part of afternoon, they will always end up raising the temperature. That is why if you have been in the northern part of the country, or if you belong from the northern part of the country to the north of Tropic of Cancer, from your childhood days, if you recall, your parents, your grandparents, they would never let you out during the late afternoon, with the fear that you will be impacted by Lu, and that would cause illnesses, that would cause fever, etc., because it would bring very very warm conditions, very very warm air. So that is what is referred to as Lu. So these are hot and dry winds which blow very strongly over the northern plains of India and Pakistan in the months of May and June, generally in the late afternoons. In the afternoons, when prolonged amount of heating has already occurred. Now, their temperature varies between 45 to 50 degrees Celsius. Now, this is an example of your typical warm advection. Warm advection. Because these are warm and dry winds which are moving over. That is why warm advection. Now, why do they become heated and warm? As they move over the region of the Thar Desert, that is when they get significant. Every year, many people, hundreds of people across our country and across the entirety of the subcontinent, they are impacted by this Lu. Few of them, they also unfortunately end up losing their lives because of sudden rise in temperature. You get stuck by heat wave of sorts, and your body gets dehydrated, and that is when few of the people they succumb to their illnesses. But nonetheless, this creates a higher temperature. Now, then we have a localized wind which tends to move in the region of North America, western coast of North America in particular, where you have the Rocky Mountains. And that is what we refer to as Chinook. Okay. So when we talk about Chinook, Chinook is the name associated with, you would have heard about Chinook as well. Chinook is the name that associated with helicopter. But what is the helicopter named after? Do we have any idea? Very good, Anurag. No, Ashad, Chinook is different from Lu. So it is basically based upon a tribe, a local tribe that you have. So that is where the Chinook, all these Apache, Chinook, etc., they have been named after the local tribes. So that is where you have the Chinook. Now, Chinook is observed or experienced, if I can take you back a few slides, and if I take you back to this particular slide, it is observed in this area, in this particular region of the Rocky Mountains. So, across the eastern slope of the Rocky Mountains, you have the warm winds, and that is what is referred to as Chinook. So that is where you experience Chinook. Now, Chinooks are also what are referred to as snow eaters, because as they are warm, they end up creating a significant amount of melting of snow in the Rockies. Now, it is not as warm as you see in the case of the Lu. The temperature of these winds is still around 4 to 5 degrees Celsius, which in terms of Indian conditions, you consider it very cold. But in those areas, even a 4 to 5 or a 10 degrees Celsius temperature wind, that will be enough to melt the ice and the snow. So that is where you have these considered to be the warm wind. So understand the phenomena. So they are blowing on the eastern slope or the leeward side of the Rocky Mountains. So when you consider any particular mountain system, let's suppose, now if the winds are blowing like this, now here, the side which faces the wind, that is what is referred to as the windward side, because that is the one which faces the wind. And the side to the opposite of it, that is what is referred to as the leeward side. So here what you experience is that these winds, they basically, as they approach the mountain side, they basically are pushed up. Okay, before that, I'll take a question which I see a couple of you have, and that is Kiran Ananya, why direction west to east in Lu? It comes from Pakistan, and when it comes to Thar Desert, it becomes hot. So in Pakistan, it is not hot. In Pakistan, also it is hot. In it basically comes from the region of Balochistan and Sindh. When you talk about Lu, it comes from the region of Balochistan and Sindh. And then it blows towards the low pressure region across the northern parts of India. So, just I'll give you a basic aspect of why that Lu comes into existence. Again, I will tell you, not relevant for your general studies, but curiosity should always be taken care of. So, here, if let's suppose you have the Indian subcontinent here, let's suppose you have the entirety of the subcontinent, let's assume. Now, during the summer months, you have a significant amount of active low pressure, very intense low pressure created here. A mild low pressure, not very high low pressure, because if you know the local topography, or if you are aware of the local topography, you would be aware that the Balochistan and the Balochistan region, that is the western part of Pakistan, that is hilly and mountainous in general, right? So it has got some low pressure, but not very intense. So in this area, you have a comparative high pressure because of the mountainous terrain which is prevalent. Okay. Now, here, that basically, this also region gets hot. This is a desertified area as well. So sometimes you have the winds coming from the region of Arabian Sea, and they provide the excess surplus of wind in this region, or surplus of air molecules in this region. Now, here, once the winds become surplus in nature, the air molecules become surplus in nature, they will take a look at where the low pressure is. Now, during the summer, in the northern plains, the temperature is what? Easily between 45 to 50 degrees Celsius in most of the areas. So that is where the winds, they move in this direction. And as these winds will blow over this direction, they will also happen to cross over the Thar Desert. And that is where they become drier. And then they hit these areas. Is that understood? Kiran, Ananya, and everyone. Is that understood, that why you have the Lu moving from west to east? Okay, good. That is not never going to be asked in the GS examination. Always, even in optional, they don't ask this anymore. Okay, those are easterlies but flow from west to east. No, these Lu is not a part of permanent wind system. Okay. So the Lu is not a part of the permanent wind system. You have to understand that. Lu is a part of a local wind system. During the time of the summer and the monsoon season, that is when they, prior to the monsoon season, that is when they come into existence. Dry in the sense they lose moisture. Yes, they become devoid of moisture as they cross over the region of Thar. Now here, Chinook. So when the winds are approaching the region of the windward side, what will happen to the wind? The wind will get colder because they are being pushed up in altitude. The wind will get colder, isn't it? They can undergo condensation, bring rainfall, etc. But after they cross over this mountain, it is not as if that mountain will provide a lift off that now the wind will rise up and go to Mars. That wind will come down. As it comes down, what will happen? There is, there will be warming or cooling. There will be warming of this. Why? Gets warmer. Why? Because of adiabatic compression. Adiabatic compression. Okay. So that is where the temperature rises. As the temperature rises enough to melt the snow. Hence, they are referred to as snow eaters. So that is what you experience in the leeward side. Windward side is the side of the mountain which is facing the wind, and leeward side is the opposite side of it. So generally, the leeward side of the mountainous areas, they are comparatively warmer. Okay, they are comparatively hotter. Now, after this, we come across a similar kind of a wind, similar to Chinook, that instead of the Rockies here, this moves across the northern slope of the Alps. Alps are present in Europe. I'm sure you would be knowing that by now due to the map pointings that we have given. So that is the local wind, which is referred to as Fohn. Now, this is also warm and dry wind like Chinook. And this also happens on the northern slope of the Alps. Here, the northern slopes, they are serving as the leeward side. So here again, the same phenomena will be experienced. So here, let's suppose this is the Alps. You have the southern slope of the Alps. And the northern slope of the Alps. So as the wind moves here, the wind will be pushed up, will get colder. And why it will get colder? Because of adiabatic expansion in general. And then eventually, as the winds they are pushed down, they move into the region of greater air density, the air gets naturally compressed. And that is when, as they get compressed, they will get warmer. So this is where you have warmer winds. Warmer winds because of adiabatic compression. Compression. Okay. That is why this wind, that is Fohn, whenever it actually comes into existence, it comes into existence in the month of spring and autumn in the region of Switzerland. And that is where it creates a comparatively warmer condition. All the surrounding areas, they are covered in snow and ice, but it creates a comparatively, it is still much colder as compared to India, but comparatively it is warmer. That is why Switzerland, or the portion of Swiss Alps, they are referred to as a kind of a climatic oasis because they provide relief from the surrounding cold conditions. And this also creates ideal conditions for the sowing of crops. So the weather becomes quite pleasant in the valleys due to the melting of the snow because the wind is warm. And therefore, valleys of Switzerland are referred to as climatic oasis because it is much more tolerable, much more pleasant. And these winds help in early sowing of wheat, ripening of grapes, and also do not allow the creation of frost. Frost is what? Frost is when the ground starts freezing up. That is what we refer to as frost. Okay? Now, after this, we have another local wind which comes into existence, especially during the winter season in the region of Europe, and that is what is Mistral. Now, Mistral gets created particularly because of the creation of different pressure zones. So, here, when we talk about the winter months, understand this. When we talk about winter months, that is when it is predominant. In comparison to the Mediterranean Sea, if you compare the land area with comparison to the Mediterranean Sea, the land will be cold or hot during the winter months. The land will be cold or hot, significantly colder. So, because the land is colder, it creates a temporary high pressure. It creates a temporary high pressure, whereas the water will be a comparative low pressure. So winds will always blow from a high to a low. So the winds will blow from this region to this region. And that is what we refer to as Mistral. So overall, if you observe, it is a cold local wind which blows in Spain and France from northwest to southeast direction. These winds are more common and effective during the winter season because of development of high pressure over Europe as the land cools down and low pressure over the region of Mediterranean Sea. The arrival of Mistral causes sudden drop in air temperature to below freezing point because these are winds moving over the colder areas. That is why that creates a sudden drop in temperature. Now, this is a cold local wind. So, in these local winds, by the way, local winds are relevant for your prelims examination in the sense that you might get an odd sub part of a question that explain or elaborate about the impact of wind on temperature factors, etc. And there a sub part of the mains question might be the what is Mistral or etc. But then this is relevant for your prelims where you need to be able to understand the region where they are existent and whether they are warm or cold. That is something you should be taking a look into. Whether they are warm or cold, or even if that is something which you are not very clear about, at least the region. So in that case, you can get a match the following kind of a question where Chinook, it is moving in North America, phone, it is moving over Europe, or it is moving over Switzerland. For example, when we talk about Mistral, it is moving over France and Spain. For example, when we talk about Sirocco, it moves over the region of Italy and Southern Europe. So that is where you can get these type of questions. Now you have another very significantly violent, cold, stormy wind, powdery polar wind, that is blizzard, which moves across the northern latitudes, higher latitudes in the region of North America, in the region of Siberia, in the region of Northern Europe. And that is where they end up blowing. These are cold winds, polar winds. Now, these winds especially pick up during the winter months. And these winds, they pick up the amount of snow and ice and the snow powder, etc. And that is when they start to blow. Now, as they pick these particular snowy powder, etc. So that is where the visibility reduces quite substantially. And also the temperature reduces quite significantly. Now, the blizzard ideally is restricted or observed only in higher latitudes, but you will experience this even in the region around United States, for example. You will even be experiencing this in the region of United States. So it is here where these winds, the cold winds will be coming over, they will be covering the region of United States. Otherwise, they are restricted to the higher latitudes. Why is it that they end up entering even into the region of United States? Because in United States and in the northern part of America rather, you don't have any east to west mountain systems. You have Appalachians here, you have the Rocky Mountains here. You don't have anything obstructing that. Just like in the case of India, you have the case of Himalayas blocking any cold winds coming from north. If the Himalayas, that is what we will study later in the portion of Indian seasons and Indian climate, that had the Himalayas not been there, Northern part of the country would have would have experienced desert like conditions because of the cold winds. Here you don't have that, right? So here, because you don't have that kind of obstruction, that is why even the areas of United States are impacted by that. So the visibility reduces quite significantly. Because of the snow and ice crystals, the speed can be as high as 90 to 100 kilometer per hour, and it causes sudden drop in air temperature to the sub-freezing level. Okay, these winds, which caused death of an Indian family immigrating on the borders of Canada. Yes, that is true. So last year, that was a sad incident which happened where an Indian family was actually trying to cross the border between Canada and United States, and they were doing it illegally. So they were moving through the rough patches. And in the winter months, in these high latitudes, everything is covered with snow, and the blizzards, they are almost a continuous phenomena over the portion of North America. So I hope when you are following the portion of international relations, when you are following the portion of let's suppose the current affairs, you are also observing that there are a lot of various different illegal migrant routes that we Indians, we are now following in order to reach Europe, in order to reach North America. So earlier people would be moving over to Canada, but Canada nowadays is not so lucrative anymore, so many people are moving over illegally into United States. So one of the methodologies to cross the border is reach the region of Canada somehow, legally, illegally, and then migrate over and illegally move over to United States. So as that Indian family was moving over, they were moving over these vast stretches of wilderness, and that is when the blizzard struck. And these can continue to exist for many, many hours altogether. And that is when the temperature dipped to sub freezing level for a continuous period of time. And sadly, the family, that is the couple and their children, they froze to death. So that is as sad as it can be. In order to search for a better life, in order to seek newer opportunities, that is where they lost their lives. So that is the impact of blizzard. Okay, so that is basically the aspect of blizzard generally observed during the winter months. Okay, so they bring about an onset of cold waves in these regions. Then we have another local wind which moves over to the region of Europe. It originates over the area of northern part of Africa, and then they cross the region of Mediterranean to reach the area of southern Europe. Now, once the winds are originating over the region of Africa, over the area of the Sahara, they pick up the reddish sand which is present there. Now, as the winds are moving over, after they have picked up the reddish sand, and then they cross over to the region of Mediterranean, where they pick up the moisture. As they hit the southern part of Europe, such as the Italian coastline, then they bring that rainfall. All the moisture that they had been carrying, they drop that in the form of rainfall. But the rainfall which happens, it will also consist of the sand particles that they had, reddish sand particles they had picked up. And that is what the reddish raindrops which appear, that is referred to as blood rain. Okay, so Sirocco always ends up causing what is a phenomena referred to as blood rain. So they move from in the northerly direction from the Sahara Desert, and after crossing over to the Mediterranean Sea, then they reach over to the area of Italy and Spanish coastline. So Sirocco, while passing over the Mediterranean Sea, picks up moisture and yields rainfall over the southern part of Italy, where the arrival of rain is associated with Sirocco is referred to as blood rain because of the fallout of red sands with the falling rains. Okay, so just like that, you have various different local winds. This is an image of it to show you the region, but then I have also provided a list of all of these. Kindly refer it for your prelims purposes. So North American local winds, you have South American local winds, you have the African local winds, you also have the European local winds, you have the Asian local winds, you have the Australian local winds. All these kindly refer to as for your prelims. Okay, please don't invest a lot of time into this. Please don't put in a lot of time and energy, because maybe every 2 to 3 years UPSC will ask this type of a question. Spend much more energy on the portion of understanding the local wind phenomena, the land, sea, mountain, sea, valley breeze, and the permanent wind systems, the pressure belts. That is where you need to invest a lot of energy. That is where you need to be revising significantly and much more frequently. Then after that, just for your prelims purposes, take a look at it so that you are not stumped by any particular name which is asked. Okay. Why Sirocco is referred to as a blood rain? Sirocco is not referred to as a blood rain, but whenever you have the movement of Sirocco, so Sirocco basically originates from the northern portion of Sahara, where it picks up the red sand particles. And these winds, they are carrying the red sand particles as they move over the region of Mediterranean. So any wind moving over a water body, it will pick up moisture as well. So that is where now these winds have the presence of moisture and the red sands. So when they will cause rainfall, that reddish sand along with the vapor will be received as rainfall. That is why the water droplets appear to be red, and hence that phenomena is referred to as blood rain. So Sirocco causes blood rain. Sirocco is not referred to as blood rain. Okay. Why Chinook are dry winds? Because whenever you have a wind coming down the mountain slope, as the wind moves up to the mountain slope, on one side they will cause rainfall. As they are pushed down the mountain slope, that is where the temperature increases. As the temperature increases, they will never cause rainfall. For rainfall to happen, as we will study in this particular chapter, for any rainfall to happen, you need the cooling to happen, because it is with that cooling that you come across the factor of condensation, because warming will never cause condensation. When that cooling will happen, that will cause condensation, that will form clouds, that will bring rainfall. So as the winds, they get warmer, they become drier, and that is where they melt the snow as well. Okay. Climatology is more conceptual than much more conceptual. Geomorphology is much more straightforward. Okay. And can we say negative lapse rate in stratosphere as a thermal inversion? Yes, sometimes it is referred to as a mechanical thermal inversion or a mechanical permanent thermal inversion because of the negative lapse rate. Okay. Does ocean current affect local or seasonal winds? Sometimes in certain areas. For example, if you talk about the eastern coast of United States, because of creation of a cold wall which happens as the Labrador current, some in some proportion it perpetuates to the lower latitudes. So that also creates a kind of a localized wind. Sinking air will always create high pressure. Yes. And is Chinook favorable for agriculture? Not so much, but because it will melt the snow, so as compared to the earlier, yes. Okay. So now we come over to the portion of, I didn't understand soil concept. Soil we have not covered till now. Which portion of soil you have not understood? Blood rain is observed in the region of Italy. Apart from Lu, India always face permanent winds. Variation of permanent winds, yes. Sinking air creates high temperature? No, not always. Climatology is very difficult portion of geography. I differ in that aspect. I differ in opinion in that aspect, because see, difficulty can be gauged by those portions. So you can have different approaches. Many of us, we have the understanding that something that you can rectify easily, that is easy. But I hold the opinion that those areas which you don't need to learn, they are the easiest portion in your civil services preparation. Climatology is one of those areas where there is no need to rectification and no need to by heart or rote learn anything. If you understand the basic concepts of temperature, pressure, entirety of climatology can be understood with these basic concepts itself. In the case of geomorphology, you might need to understand the landforms, etc. You might need to learn them. But in climatology, if you're these basic concepts, what we have covered in the early two modules of climatology, if those basic concepts are clear, you will never face any problem. If the regardless of the type of question that UPSC throws at you, you will be able to take it up very easily. Okay, so here the crux is to understand the concepts rather than trying to rote learn everything and trying to retain everything. If you try to do that, then it will be the toughest portion, not only in geography, but in the entirety of your preparation. You will find that learning the dance forms in art and culture to be easier than learning the various wind pattern, etc. If you're trying to learn it, if you're trying to understand it, then it is a kind of a very simple aspect. Is blood rain observed in India? No. Sakshi, what particular portion of soil you have not understood that you were talking 1 minute before now? Kindly be more specific. Kindly be more specific. Which portion you have not understood? Enum, what are occluded fronts? Enum, then enlighten the class about what do we mean by fronts, first of all. So once we have not covered that particular topic, if I start explaining occluded fronts, what will the rest of the session do? And then if I ask you certain questions about cold and warm front, will you be comfortable with that? So wait for some time, my dear friend. I'll talk about the occluded front. I will talk about the warm front, stationary front. I will talk about the stages of temperate cyclone. Just hold your horses. Have some patience. Sirocco. Okay, that is the issue. Okay. So I guess any issue with Sirocco is primarily because of an inability to imagine the aspect of world map. That is what I had been trying to instigate. So this is where Sirocco is in existence. This is your portion of Africa. So as the Sirocco originates from here, it will pick up red sand, because I hope we are aware that this portion of Africa is a desert. This portion also consists of significant amount of red sands. And this is a region which is dominated by features what are referred to as regs and hamadas. So as you have this wind which moves from here, it will pick up these red sand particles. So let me do one thing. Let's suppose this is the land, or let me use a different color altogether. Let's suppose this is the land of Africa, followed by the Mediterranean Sea, followed by southern part of Europe. So as the wind moves from here, it will pick up these reddish sand particles along with that. We have seen in the portion of landforms and wind erosion and wind landforms. So as this reddish wind then moves over to the region of the Mediterranean Sea, it will pick up some amount of moisture as well. So now this wind has got reddish particles along with lot of moisture. So when they will cause or form clouds and bring rainfall here, so these red sands that it had picked up along with the moisture, that is something which will be received. So this is what is referred to as blood rain. It is not the problem of not able to understand Sirocco. It is that blood rain creates so much amount of intrigue that where is it that blood is raining? Something that we have seen only in the movies. Is it now understood? Is it now understood? Or is it still the factor of blood which is creating that kind of intrigue? Okay, understood? Good. Why sand is red? Because of the presence of iron particles. Because it is rich in iron particles. That is why. That has got nothing to do with the horror movies that you have been seeing from the childhood days. It is a very natural phenomenon. Okay. Mistral region is the region of Spain and France. Okay. This rain is harmful or not? Wherever you have the sand particles falling with the rainfall, obviously it will cause corrosion in the various monuments as well. It will have certain impacts there as well. Shubham, what you are saying in the portion of Kerala, that is very much associated with the aspect of acid rain. Okay, where you had the dry deposits of acid. Okay, I hope that is understood. Bloods, or rather wind blowing downward down the slope of mountains create high or low pressure. It create a high or low temperature. It creates a higher temperature. Can we move ahead, guys? Okay. Why the Sahara Desert is so large? That is because it is an entire region of subtropical high, and there the wind pattern that you will see is offshore. The trade winds are offshore. That is why it creates a dry condition. If ever you are interested to know more about Sahara Desert, always understand that Sahara was a region covered in rainforests. A few thousand years back, a few million years back, Sahara was not always a desert. Sahara has become a desert very recently. I mean, when I say, again, let me put it in perspective. When I say very recently, does not mean a few years. That means a few thousands of years ago, Sahara has become a desert. Before that, it had trees, it had forested area. But when Africa was still significantly to the south, Sahara would receive significant amount of rainfall. Many areas would be covered underwater. That is the reason why you have the regions such as Libya, Algeria, etc., still having significant amount of oil reserves. That is the reason why you have many areas having red sand because of the iron which would be present there. Okay. Powdery means powdery. I hope we understand powdery, where you have very fine particles, small particles, that is represented by the powdery. Polar here refers to something which originates from polar region. Okay. Now, coming to the portion of humidity and precipitation. So when we talk about humidity and precipitation, this is going to be relevant both for your prelims as well as for your mains exam. In the case of your prelims, even though UPSC has not asked this for some time, but you never know, the pattern is changing. So basically, you will observe here questions about basic difference in humidity types, then basics in terms of types of cloud, types of fog, types of rain. Then in the mains exam, that is where you have conceptual questions asked from this particular portion about. Here you also had a question which was asked once about thunder and lightning. In the mains exam, you get questions about types of rain, you get questions from the portions of hailstorms, cloudbursts, types of fog as well. So these are the basic areas where we will put all our attention and focus upon. When it comes to the different types of, let's say, humidity, etc., these are very simple ones where we just need to understand how the humidity is basically measured, how that humidity is observed. That is all that we need to be focusing upon. And then we will be talking about how is it that the cloud gets created. Right, we will talk, we'll not go into the names of the various different theories. I don't want you to get confused in that. We will be talking about how is it that the clouds get created, what is dew and dew point temperature. There again you can get a prelims question about. Okay, so dew and dew point. Heat budget, for a very long period of time has not been asked in the examination, Rashida. So that is why I have basically eliminated it from the portion here. So you can cover it from the tablet if you want. There we have covered it, or you can cover it from the portion of the NCRT also. Okay, so that is heat budget. UPSC has not been asking it for a very long time because it is something which UPSC has asked in the optional area of geography. But then here in GS, it is not asking because it is straightforward. It is very simple and straightforward. Okay. Now, that is what we shall be looking into. We shall be understanding what are the various different methodologies of precipitation, what are the various aspects of precipitation that we are going to concentrate upon. So we start with the portion of humidity. So when we say humidity, what do we mean by that? Now, by the way, guys, before I forget, all of you who are present here, for tomorrow, I want you to do a basic homework on one of the topics, and that is latent heat. Those of us who know this, fair enough. Otherwise, I need you to find out what do we mean by latent heat of condensation. I need you to have an understanding of this. This is something that you study in your class 8th or ninth standard, if I'm not mistaken. I hope and I expect this much basic amount of homework and prior work from you before you come to the session. Okay. So, what is meant by latent heat of condensation? Is that a heat which is consumed? Is that a heat which is supplied? Take the help of Google, take the help of your childhood books or your school books if you want, wherever you want to take, or you can take the case of the basics of climatology in the tablet as well. Wherever you want to take a help from, take a help from that. I want you to be very clear about what do you understand by condensation, vaporization, melting, solidification. This basic, I don't want to be spending energy and time here to explain to you guys that how ice gets converted into water, how water gets converted into vapor. If we are indulged in that kind of a discussion, then there is no point of talking about the tropical cyclones and the occurrence of tropical cyclones. So latent heat, I hope that much amount of work you will do. Rashida, is it not there? Please ask for the updated memory card in that case. I think it should be there. If not, ask for the updated memory card. Now, then we talk about the portion of, or we come to the portion of humidity. So, humidity is something that we encounter on a day to day basis. So, humidity is what? Humidity is the presence of moisture in the air. The total amount of water vapor that we have in the air, that is humidity. Now, many of us, we mistake water vapor with the liquid water droplets, right? That is very different. Vapor is the gaseous form. So, the presence or the content of vapor in any column, any parcel, any sample of air, that is what is referred to as humidity. Now, here, when we talk about humidity, basically, always I want you to approach it from the very basic. Whenever you have a confusion, approach it from the very basics. So, for example, if you consider any color sample of air, now this will have air particles, gaseous molecules in between amongst themselves. Various different gaseous molecules, various different dust particles will be included here. Now, in this case, you have liquid water droplets, or rather, not liquid water droplets, but gaseous vapor particles. Pardon me for that. So, you have gaseous vapor particles which are trapped or which are contained in the air. So the content or the amount of these particles, these vapor particles in the air parcel, that is what is referred to as humidity. Okay. So refers to the amount of water vapor present in a parcel of air having definite volume and temperature. So we experience this. For example, any of the times when you have basically visited, let's say, a region, let's say Chennai or Kolkata for that matter, or Mumbai or maybe Goa. Now, you would have experienced that despite the heat which is present, you start perspiring, you start sweating, but that sweat doesn't evaporate. And that makes you feel very uncomfortable. Why is that? That is because there is already so much amount of water vapor present in the air. The air doesn't have the capacity to take in more water vapor. And that is why your sweat or your perspiration doesn't evaporate. Conversely, if you go to, let's say, Jaisalmer, or even for that matter, Delhi during the summer season, now in those areas, the temperature is higher than what you experience in Chennai or Kolkata or a Mumbai or a Goa, but the amount of discomfort is not very high. Why? Because there, when you perspire or when you sweat, the air around is so very dry that there is evaporation of that sweat particles. And whenever evaporation happens, there is a cooling. So that is why your body is able to adapt. But then, in these coastal areas, because the moisture level is so high, the humidity level is so high, that it doesn't have the capacity to take in any more amount of vapor. So that is why you continue to sweat profusely. There is no cooling in your body temperature rises up, and after a point of time you feel dehydrated. Okay, so that is the aspect of humidity that we encounter in our day to day lives. But when this moisture content is very, very low, for example, uh, the region which got significantly highlighted even in national headlines was basically the region of Bangalore. Now, Bangalore during the months of April and May, even late March, April, and May, the wind movement is so very strong. Now, that takes all the moisture away. And that is where in Bangalore, the humidity levels they get so very low that it becomes almost dangerous for the skin. The skin dries out very, very quickly. And that is when you have dry wind and dry air rubbing against your skin develops a kind of a charge. And that is where in Bangalore, all of you who have lived in Bangalore, or all of you who have your friends there, if you ask them or if you have followed the national headlines, then you would have observed that during that point of time there was a lot of news about the static electricity, where if you touch any particular thing, then you will feel some kind of a charge immediately because of the dry air rubbing against your skin develops a kind of a charge. So that is how moisture presence impacts us on a day to day basis. Now, this moisture content in a particular air parcel or air column is observed, is experienced as, or is something which is dependent and influenced even by temperature factor. How? So let us understand that. Now, before that, when we talk about the amount of water vapor present here, the air at any particular temperature will be able to accommodate only a limited amount of water vapor. It is not as if the air will continue to take in water vapor endlessly. So, the amount of water vapor that an air parcel can carry at any given temperature, that is referred to as the carrying capacity of air. Amount of water vapor that an air parcel or an air sample can accommodate at any given temperature. That is what is regarded as carrying capacity of air. Of air. Okay. Now let us understand the influence of temperature when it comes to the air and humidity. So let's suppose I have an air parcel. Now, if I heat it up, and then we will consider a situation when I cool it down. So let us consider under normal conditions, these are the gaseous particles and the dust particles which are present in the air parcel. So water vapor will be accommodated where? In between them. Okay. Now, if I were to heat this up, if I were to provide heat to it, then the particles will gain energy. The gaseous particles, dust particles, they will gain energy. They will start escaping the system. That is why the air becomes lighter. So that is where, as the particles gain energy, they will start moving away from each other, distant from each other. So what can we say about the carrying capacity of air? Now you have greater amount of space where that water vapor can be accommodated. Greater space for the accommodation of water vapor, isn't it? So this is where the carrying capacity, can we say that the air's carrying capacity has increased. So with heating, carrying capacity of air increases. We can say that, we can have this conclusion, isn't it? Then what if we cool this down? So if I were to cool this down, the particles, they will get much closer to each other as compared to earlier. If I cool this down, so the particles will get much closer to each other. That means there is a lesser space for the accommodation of the moisture particles or the water vapor particles. So you have lesser space for their accommodation, comparatively and significantly lesser space for their accommodation, isn't it? So carrying capacity reduces as there is a drop in temperature. Okay. Now, whatever the air was carrying as the water vapor particles earlier, now here the carrying capacity is reduced. So the air cannot accommodate that much amount of air particles. Let's assume it was carrying 10 grams of air, of moisture earlier. Now it is able to accommodate, let's say, only 5 grams. So what will happen to those extra 5 grams which were included in the air earlier? Apply your logic here. All of you, I want you to apply your logic. What will happen? It will be incorrect. So what will happen to that extra 5 grams which were included earlier, but now the air cannot accommodate them? So when you cool it down, let's suppose earlier the carrying capacity was 10 grams of vapor could be carried. Now the carrying capacity has reduced only to 5 grams. So what will happen to the extra amount of 5 grams? Very good. Even if they will merge, how will you remove the weight of it? They will condense. The extra 5 grams which were there, they will begin to condense. We'll talk about it later on as well. So here, water carrying capacity of an air parcel varies with the temperature of air. A warmer air parcel can hold more amount of vapor as compared to the colder air parcel. That is why when you increase the temperature of air, its moisture carrying capacity increases, and when you decrease the temperature of air, its moisture carrying capacity will always reduce. So increase in temperature, I will write it again. Increase in temperature increases the moisture carrying capacity, the moisture carrying capacity, and the opposite of it also happens. Okay, till this portion, I hope it is understood. Okay, the number of molecules in a parcel of air will be the same. No, when you heat it up, the in that parcel or in that volume, many of the particles will escape that system. Few of the particles which were earlier present, they were escape or they would escape that system. So you have lesser number of particles in that. Okay, right? Means hot air contain high moisture content? No. Means hot air can contain high amount of moisture content. Okay. That means colder regions will have humidity will be present everywhere. The amount of humidity will vary. Okay. How, sir, heated air have carrying capacity? So heated air, basically the gaseous particles will end up moving away. So that is why you have a lot greater amount of spacing, and that is where you can accommodate much more amount of water vapor. The extra 5 gram Nagentron, the extra 5 grams which will be there, that will condense. Earlier you had 10 gram, because of cooling, it can accommodate only 5 grams. So the extra 5 grams that you had, they will condense. Okay. So that is the aspect of humidity and temperature. We'll talk more about it in terms of the aspects of various different types of humidity as well. We'll talk about it tomorrow. Before that, since many of you had raised the issue of discussion of these questions. So, by the way, how many of you have taken a look at these questions? I understand that many of you are completely dependent that when it will be discussed in the class, only then I will take a look into that. Otherwise, I am happy in my life. Map pointing I'll give you tomorrow. But I'd asked you to take a look at these particular questions. Yeah, I understand many of you have not seen. Right. Yeah, few of you have submitted for evaluation as well. So I I I had asked you that if you had any doubts in these set of questions, that is what we will discuss. So after heating of the air, will the evaporation happen? Yes, it can happen. Evaporation happens on the ground surface. In the air also it can happen. We'll talk about it tomorrow then. So here let me tell you what is required to be written in these particular questions. So explain the formation of thousands of islands in Indonesian and Philippine archipelagos. Why is it that we have thousands of islands in the Indonesian and Philippine archipelagos? Why is it that we have thousands of islands in Indonesian and Philippine archipelagos? Very good. Yashwant, correct. Manikandan, correct. No, Kirtana, these are not volcanic hotspots. This is because in this area you have oceanic convergence. Islands are created always in the case of oceanic convergence. So in this answer, you basically, what is meaning the meaning of archipelago? A group of islands. So in this particular answer, you had to bring to the equation that it is an area where you have the Pacific plate, which is undergoing subduction in the underneath the Philippine sea plate and the Caroline sea plate, and that is why you have significant amount of volcanic eruptions happening in this area, and that is why you have the creation of these active volcanoes, seismically active regions, and also creation of these chain of islands. Okay, so that is all that is required to be written. So in this, you have to indicate a rough map. You have to indicate the schematics of what happens in the case of oceanic convergence, the one that we had discussed. Okay, right? Now, could this answer be written by this much classes? Absolutely yes. If with the classes, if you are not able to write these questions, then I don't know when will you be able to write this. Absolutely yes. So now the other question: why are the world's fold mountain systems? Dhanya, what is it that you are not able to understand, dear friend? Please let me know. Convergence and subduction doesn't mean the same. No. Convergence doesn't mean always there will be a subduction which will happen. Convergence can be of various different types. Subduction generally happens of the heavier plate. Okay. Now, why are the world's fold mountain systems located across the margins of the continents? Bring out the association between global distribution of fold mountains and earthquakes and volcanoes. Now, it is a two-part question. It is a two-part question. Okay. How active volcano play a role in formation of island? Not always will an active volcano lead to a formation of an island. Kindly take a look at the recording of the videos when we were talking about the portion of convergence and plate tectonics, where we had said that as the heavier plate subducts underneath the other one, now if this is covered underwater, now here you will have the portion which starts melting. As it subducts, it will undergo melting, and because some amount of water will also percolate, so there will be pressure, the water vapor which will provide that pressure, and here underwater you have volcanic eruptions. As the convergence continues due to slab pull or due to other endogenic forces, this will continue to grow further higher up till it emerges above water. And that is what is an island, isn't it? What is an island? Island is a land area which is surrounded by water from all sides. So that creates a kind of a volcanic island. Why does it happen in a group? That is because, is that convergence happening only in one point? These plates, they are very, very large, isn't it? Spreading across thousands of kilometers. So if that plate across thousands of kilometers undergoes the subduction, won't there be a kind of a volcanic eruption happening all across? If I have to represent this with a kind of an image format, can I represent it somewhat like this, that this entire region is undergoing subduction? It is undergoing subduction across, let's suppose, this entire stretch. Can I say this? That it is undergoing subduction underneath the entire stretch here. And in this entire region, as this subduction will happen, it will start melting here. The materials will then start to rise up. So across this entire area, won't we experience significant amount of volcanic eruption to happen? Is that understood now? Is that understood or no? Good. Yes, these questions are there in the weekly test also. Why are the world's fold mountain systems located across the margin of the continents? Which fold mountain systems are we talking about here? We are talking about the region of the Rockies, the region of the Andes, the region of the Atlas. These are your fold mountain systems across the mountains. Appalachians as well. Himalayas are not at the margins of the continents. Himalayas are bam in the middle of the continent. So those are the areas that you have to highlight because there is a convergence. So here you have to talk about the convergence. Continental oceanic, and that has created the various different types of fold mountains. That is something that you will address in the first part of the question. In the second part of the question, you have to talk about the distribution of the fold mountain system. Here you have to talk about the Alps as well. You have to talk about the Himalayas as well. You have to talk about the Urals as well. You have to talk about the Atlas as well. You have to talk about the Andes, Rockies, all of them. You have to indicate them on a rough map of the world, very rough map of the world. And you have to indicate that why is it that the earthquakes and volcanoes happen in this region. Again, a schematic image is required where you indicate that there is a plate movement. Whenever that plate movement will happen, it is very rough, and that is why you have a earthquake and volcanic eruption. Okay, is that understood? Good. Define mantle plume and explain its role in plate tectonics. Any difficulty in this particular question that you have? Any of you? Any difficulty in this question? Any of us? We have the exact definition of mantle plume given in the PPT, right? And what is the role in plate tectonics? Chavan, what is the doubt that you have, my dear friend, in this? Its role in plate tectonics. Okay. So when you have a mantle plume is basically going to produce heat. If this is the region of the crust, from the region of the mantle plume, you have the production of heat. Now, that heat over a period of time, it can lead to the presence of a convection current, isn't it? And that convection current can lead to the weakening of the crust, can lead to the divergence of the crust in this region, creation of mid oceanic ridges, creation of a newer crust here, and this will be pushed aside. So, it can lead to convergences and transform plate movements in other parts. Is that understood, Chavan? And also another one, Sindhu. Is that understood? Or is there any doubt? If you have doubt, please don't hesitate. Ask it up. Okay. Parasitic cone is when you have a volcanic eruption and significant amount of a volcanic landform which is getting created. Now here, if let's suppose this is the vent of the magma chamber, now it will be solidified after some time. Now, once it is solidified and significantly hardened, for the molten matter to exit from here, it becomes almost impossible. So, that is when sometimes what happens from the weaker fracture zones, you have a volcanic eruption supplied from the same magma chamber. That is a parasitic cone. So, that is something that we have covered in the portion of the portion of composite volcanoes, the stratovolcanoes that we have talked about. Okay. Now, discuss the geophysical characteristics of circum-Pacific zone. Any issue in that? What to be written about the distribution? Are you talking about the distribution of volcanoes, distribution of fold mountains there? Are you talking about that, Sindhu? So distribution of fold mountains, you have to indicate where the fold mountains are present. You have to indicate where you have these earthquake and volcanic eruption. Again, flip back to the PPTs. We have indicated the region. So in distribution of volcanoes and earthquakes, you have the regions of circum-Pacific zone. You have the Mediterranean region. That is where the volcanoes occur. So that is what you will have to highlight in the case of fold mountains itself. Okay, because otherwise you have eruptions happening even in the region of volcanic hotspot and eruptions of volcanoes happening across mid oceanic ridges as well, but that is not associated with the fold mountain, so those did not or those need not be highlighted. Okay, right, this last process is not an adiabatic situation. Which last process are we talking about? Convection current is invisible radiation type or any molten material. It is basically the molten material. As the heat starts rising up, that starts melting materials above it, and that is how you have the movement of the particles, because the mantle is significantly compressed, and that is why it can get deformed easily rather than breaking. Bhagya, we have to discuss the mid-Atlantic ridge in this? No, absolutely not. About the humidity example. Okay, so we have doubt in the humidity example. Let me go back to that. Which portion are we having no adiabatic aspect are we talking about here? No. Chandrasekhar, I'm not understanding how heating of air will have a capacity of carrying water particle. So when you have the heating of the air parcel, understand this basic thing. Whenever you heat up any air parcel, if this is the air parcel, let's suppose, here you have the various different gaseous and dust particles which are present. Now, when you heat it up, all of them will gain energy, all of them will start moving away from each other. That is what happens when you heat it up. So, this air parcel will have what? Lesser number of particles as compared to earlier, because many of them would have escaped the system. So, as compared to 1, can we say that 2 has got a greater capacity to accommodate water vapor because there's a larger gap available where the water vapor can be fit? Is that understood? Or is there a doubt which still prevails? Good. Pooja, Himalayas is located at the margin of which continent, my dear friend? Which continent's margin is present at the region of Himalayas? Let me know. Condensation, Saubhagya, we will talk about it tomorrow once again. Don't worry. Yes, yes. If you don't have any further question, you can leave the session. This was the last question. Roshan, what is your question, my dear friend? See, I'm consistently taking the questions. It is not as if I'm not taking the questions. What is the use of the cone shape of the mantle? It is not as if it solves a particular purpose, but as it starts melting, it will generally the molten portion, because it is lighter, it will tend to accumulate on top. That is why it forms that conical shape. Okay. Till now, we have not covered those questions and answers of theory. Which question? We have covered about how to write answer. We have covered it in detail, that what needs to be written in introduction, what needs to be written in body, and what needs to be written in the conclusion. Roshan, kindly check the recordings when we were discussing about the portion of continental drift theory. We have discussed how to be written in an answer. Do you want me to discuss that what needs to be written in introduction, body, and conclusion of each of the answer? Is that what you are expecting? I hope not. Because if I'll tell you about all the PYQs, where is it that you will try to write it on your own? Because UPSC might not repeat these same questions. Where will you get the practice of that? Kindly write it on your own. Answer of the geophysical characteristic. Okay, let me tell you this. So in the case of the introduction here, let me tell you this particular portion. In the case of introduction here, you have to write about, I'll not be able to write the entire answer. I hope you understand the aspect. So in this case, you have to write about what is meant by the circum-Pacific zone of fire. So what is it? So circum-Pacific zone is the entire region around the Pacific Ocean, around the Pacific plate. As the Pacific plate is undergoing convergence, this is a zone which is geologically very active. That is what needs to be written in the introduction part. When we talk about after the introduction, what do you need to write in the body of it? First of all, you need to elaborate what happens. What happens here? After you talk about that is you have seismic activities, you have volcanic eruptions. Then after that, you need to write why it happens. There you have to explain convergence. Which type of convergence? With the images, you have to indicate oceanic, and oceanic continental, right? Then after that, you have to indicate impact, creation of islands, seamounts, trenches. And then after that, you have to write the conclusion of it. In these, you have to give examples and images. And then conclusion, you have to write that this is an area which is geologically very active, because the Pacific plate being one of the oldest and the heaviest one, that undergoes continuous subduction from all different sides, and that is the reason where how it impacts the entire region, both anthropogenically as well as ecologically. Is that understood, Roshan? But sir, you said that sweat does not dry up in humidity. Then how the heated air can have higher? So humidity, if humidity is high, does not mean temperature will be high. Humidity is high does not mean we have not said that with heating the humidity will be higher. I have just said that with heating the carrying capacity will be higher. Whether it is carrying that much or not, that is dependent on the ground factors and the other conditions. So heating does not mean automatically humidity is higher. Is that understood? Lakshmi, the answer of geography needs to be same like other subjects. Absolutely not. If you are writing the answer just like you are writing the other subjects answers, then you will never get marks in geography. You have to represent it with images and maps. Pacific Ring of Fire is not because of divergent plate boundary. Divergence of plate in the Pacific, in the entire Pacific, is happening only in the case of the Chilean rise, where you have the Nazca plate. Otherwise, everywhere around it, you have the convergence. So here you can explain the portion of the mid-oceanic ridge, even in the case of the Nazca and the Pacific plate, but otherwise, everywhere around it, you have convergence. Yes, if you don't have any question, you can leave the class. Any standard book for geography for good answer writing? NCRT. See, if you are expecting the questions to be picked up directly from the book and then put into the exam paper, so that you read the content from the book and you can put it in the exam paper. So let me break it to you. This is not the class 10th or 12th exam that you are appearing for. Here, any topic that you might have heard from, that is where the questions are framed. So that is where you need an understanding. If you understand it, with the help of example, you can always write the answer. Okay. Okay. So that is where we'll restrict the session here today. Volcanic hotspot and chain of islands in last question, you can, but that is not a part of the circum-Pacific zone. That is only in one region that you have. Okay. Bend is in same direction in northern hemisphere. It is in same direction in both the hemispheres. So in northern hemisphere it comes out to be the rightward bend. In southern hemisphere it comes out to be the leftward bend. Yes, world map needs to be drawn. Okay. So that is where we'll end the session here for today. Any further questions will be taken care by the SMEs. So we meet again tomorrow. Take care of the portion of the latent heat of condensation. Do look it up. And when we meet tomorrow, we will continue further. So take care of yourself. Goodbye. Thank you and have a good night.